All of that is underpinning distinct responses to climate and land use change. But we still lack basic knowledge about what's underpinning those mechanisms and how that should or could influence climate adaptation and mitigation decision-making. Got it. This mouse does not want to work with me. Bear with me 1 second. This is when you just wish things were touchscreen. If you guys could see how difficult this is on my end, I promise you I'm trying really hard. Got it. Thanks, Bob. You come up here and magic happens. No, it's great. Thank you. Okay. So the 3 pillars of PANGEA are to advance the science, first and foremost. Our scientific understanding of the region and the differences from one tropical region to the next is critical. And it's a major priority for PANGEA. The second is capacity building. There's an opportunity, we believe, with PANGEA to train the next generation of scientists, in particular scientists from the region, to be able to lead these efforts into the future. And the third pillar is advancing monitoring. There's an amazing amount of satellite remote sensing capabilities in orbit right now. And in order to leverage those, there's a lot of work that needs to be done, which PANGEA can support to calibrate and validate and understand what we can and cannot see from those data sets that will allow us to advance the monitoring capabilities of everything from carbon to biodiversity to agriculture. So I want you all to take a quick minute just to turn to somebody next to you. And I think many of you know people you're sitting next to, so maybe turn behind or in front. Just introduce yourself. What's your name? Where are you coming from? What's your area of expertise? And what do you hope to get out of this workshop? Okay, wrap up your introductions. So one of the other things we heard, or I heard in a lot of the surveys that were submitted prior to the workshop, was how excited people are to connect in person with other folks working in the tropics who care about this part of the world. So it is my hope also, in addition to having a lot of productive conversations, that there's a lot of collaboration opportunities that are fostered here. I think that's a real desire for many people in the room and online as well. We have a lot of Zoom participants who will engage throughout the next 2.5 days. So please continue the conversations that just started and get to know one another. We do have over 130 participants in person who will be joining over the next 2.5 days, 140 plus people who are registered to join on Zoom. We have a lot of representation from across the world, which I'm really thrilled with, and a lot of different institutions represented. So again, please get to know one another. There's a real opportunity with all the people who are involved to make connections that could lead to a lot of research opportunities down the road. So our workshop goals for the next 2.5 days are to share information with the community, you all and folks on Zoom, and all of this will be online and made available as well, to share information about the scoping process with the community early enough in the process for feedback and engagement. I'll talk more about our timeline and what this process actually looks like in practice, but we're still early enough in the 1-year scoping effort for you all to be really involved and provide a lot of input. We want to solicit feedback on the campaign design. That includes the science questions and the geographic scope. And we want to identify and discuss existing efforts that align with the potential campaign. I listed a lot of partners we're already discussing, but really figuring out which priorities PANGEA should emphasize in relation to existing efforts is going to be a really important part of these conversations. So today I'll move in after some brief remarks from our program manager, Ryan Pavlik at NASA, about what is PANGEA. And then we'll hear about 2 examples of past NASA campaigns that were highly successful. In the afternoon, we'll hear from a lot of the working group co-leads about what they've been up to and where they're headed and where they would like input from the community. And we'll discuss capacity building opportunities at the end of today. Tomorrow, we'll move into a panel discussion where we'll hear from a lot of folks at NASA about relevant satellite missions and airborne campaigns. And we'll move into, after a coffee break tomorrow, involvement in PANGEA. What should that look like? How can we make sure we're doing that effectively? Tomorrow afternoon, we'll have a round of lightning talks from a lot of folks who are working on various scientific efforts in the tropics. And this is going to be an idea or an opportunity to kind of hear the latest about what's going on. We'll have time for questions. And then we'll move into a session at the end of tomorrow on end user needs. So thinking about these monitoring capabilities and the data products that might come out of PANGEA, how can we be thinking about that from the beginning? And then finally on day 3, Thursday, which is a half day, we'll start with making the most out of the scoping process. There's a lot that is already emerging just from this scoping process. A lot of information that's being gathered, a lot of connections that are being made. And we want to make sure that we're really putting as much effort as possible into making sure that's shared with the community. And we're leveraging that and doing as much as we can, even just with this scoping process. And then we'll wrap with synthesis and takeaways and really think about next steps to make sure we can continue to engage all of you and the rest of the research community. And then we have a few optional activities. We'll hand out Metro cards. There's a lot of great things to see in this area. There's a chance of rain, but hopefully it'll hold. We'll see. But there's a few different activities that folks have volunteered to lead, including visiting the Smithsonian Museum of Natural History, the Botanic Garden, and the Monuments Park. So just a couple more, or one last thing before I hand it over to our program manager at NASA. I want to emphasize a few different links that will be useful to you all. And it looks like there's an updated version of these slides that I will make available that have a tiny URL as well. So I'll put that in the welcome packet and maybe I'll flash that up after the coffee break as well. So you have these not just with QR codes, but with a tiny URL. So the first is our PANGEA website. The activities page in particular has information about this event and lots of other events. It also has the updated agenda that you can download as a PDF. In English. The welcome packet has translations of that in French, English, Spanish, and Portuguese. It also has some Google Docs that you'll be using in breakout sessions. And then on the right is the Google Jamboard, which if any of you are interested, you can log onto there and post a digital sticky note or many at any point in time. And that's going to be an opportunity for you to share your thoughts live during the meeting The leadership team, especially myself and Isaac, will be taking a look at that throughout, and we'll make note of questions, ideas, thoughts as they arise. So again, I'll make this available after the coffee break with the tiny URLs as well. So now I want to pass the microphone over to Ryan Pavlik. I want to just briefly say that the terrestrial ecology program is what put out the solicitation and is funding these scoping efforts. And we're incredibly grateful to Hank Margolis, who was in the position of program manager when the solicitation was put out. He's since retired in December of last year. And in the interim, Mike Falkowski and Kathy Hibbard have been incredibly supportive and helpful to us through the process. And then just very recently, Ryan Pavlik stepped into the role of program manager for TE. So it's my great pleasure to welcome Ryan here to welcome the event. Thanks.
Well, thank you, Elsa. I don't have a whole lot to say because that was a wonderful introduction of kind of what PANGEA is and what the TE program is at NASA. So really, I just want to reiterate some of the thank yous. First of all, thank you to all of you for coming being here online with us. Some of you are coming from very far away. You're away from work, you're away from your families. So thank you for coming. This scoping process is inherently collaborative. It has to involve many different people coming together, figuring out how we can make such a campaign work. So the only way to make that happen is for people to come together. Then I want to thank Isaac and the rest of the PANGEA team for doing a great job with organizing this and the scoping study so far. And thank Elsa for both her vision and her leadership. I remember we started this process, what was it, 2020? It was during COVID. Elsa came to JPL asking, how can I get some flights in Central Africa? I'd really like to just, fly a couple of flight lines. And we started, brainstorming, and then somehow it spiraled, and now we're here 4 years later. And have all of you in this room, and it's become a real thing. So thank you. Looking forward to this workshop. Looking forward to meeting many of you, and yeah, feel free to come up and tell me about where you're coming from, and I'd like to talk to all of you while I'm here. So thanks.
So Ryan revealed a couple things there. One, that I have long worked in Central Africa and have a geographic bias for that region, but we are thinking pantropically. We'll come back to that. Two, Ryan actually, I think just for full transparency, was at JPL prior to stepping in as program manager of the TE program. And he was actually on our leadership team for PANGEA. He is no longer on our leadership team, and to avoid any conflict of interest, I'll talk about a second scoping effort that's ongoing. Ryan and the rest of the folks at NASA headquarters who are going to be involved in this decision-making process are stepping back, so there's no bias there. But we're incredibly grateful to Ryan, especially in the early days of the PANGEA development process. So I think we're going to start in just a moment to move into session one. All right. Thank you, Bob. Okay. So we are now moving into the first session. You're going to keep hearing from me for a little bit because I want to make sure everybody's on the same page about what PANGEA is. And then we'll have a coffee break. So bear with me. I don't think I need to actually remind everyone of this, but I'm going to anyway. Forests are incredibly important. This is a beautiful map that was created by Greg Fisk at what is now the Woodwell Climate Institute. And this is showing basically a topography map or elevation map of carbon, above ground carbon across the world. And you can see that areas that really pop are these tropical regions. And we know these systems are important not just for carbon, but for many, many reasons. So despite covering less than 10% of the ice-free land surface area, the tropics maintain over 2/3 of all species on the planet. They're home to more than 3 billion people. And for the rest of the world, including the folks who live there, but many of us here in other parts of the world, they're incredibly important for regulating local, regional, and our global climate systems. The tropics constitute a really important water and heat pump that regulate these systems. And then coming back to carbon, we do know that they're incredibly important for carbon cycling. So they account for over 30% of terrestrial net primary productivity. And depending on your estimate, and there's many different estimates, they store anywhere from about 25 to 40% of total terrestrial biomass. They're critical. They're also changing incredibly rapidly. So tropical ecosystems are entering what we call a no analog state, meaning that they're going to be compositionally different than anything that's found today, which has implications for how species and the systems will respond. Temperatures are going to be hotter in this region, in most of the tropics, than these systems have experienced in much of their evolutionary history. So this potentially means things like range shifts, adaptation, acclimation. What that's going to actually look like in reality is still a major knowledge gap. There's also a huge amount of human-induced change in this landscape, more directly in the form of cropland and pasture land expansion. The single greatest driver of deforestation globally is cropland and pasture land expansion, and 80% of that forest conversion globally is happening in the tropics. A lot of that conversion is for agriculture, which is, again, not just for people living in that region, but also for the rest of the world. There's people all over the planet who depend on food production in the tropics and fiber and biofuel production. And that agricultural production is going to be directly influenced by changing temperatures and rainfall patterns. And again, we still have very little understanding of how climate change is going to influence things like ag production in this part of the world. More broadly, the tropical structure and function, we have a sense is going to be increasingly diminished by the end of the century, resulting in a lot of these different feedbacks related to water, temperature, energy cycles. But we still remain quite in the dark when it comes to understanding exactly how these changes are going to proceed. So despite having a huge impact on the entire Earth system, this part of the world is still severely understudied, and we lack basic knowledge about a lot of these systems or aspects of these systems. This is an example now zooming out to the entire global land flux. You're seeing here an example of 11 different Earth system models that I'm showing you to highlight just the huge amount of uncertainty when it comes to, for example, future carbon flux dynamics in the region. So there's a lot of differences in these models, but what I want you to focus on is that by the end of the century, these models don't even agree in what the land flux will do. So some of these models actually predict that terrestrial systems could be storing carbon, as they are most years today. And some of these models actually predict that these systems are going to shift to being sources of carbon to the atmosphere. There's a really nice study that emphasized how much of this uncertainty is constrained to our lack of understanding about the tropics. So it's a little bit hard to see, but on the left or on the y-axis, you're seeing model variation and net ecosystem productivity trends from 2000 to 2019. And on the x-axis is latitude. So that latitudinal area that's highlighted in that red box is the tropics, and you can see about 3 times greater uncertainty in ecosystem productivity estimates across these models. So these models are incredibly uncertain, and most of that uncertainty is in the tropics because of our lack of understanding of these systems. I would argue, and what we're trying to push with PANGEA is the need to recognize that ecosystem heterogeneity is critical. We can't treat these systems as a single monolith, even though it is a single biome, and recognizing and unpacking what aspects of heterogeneity is increasingly critical for constraining this uncertainty. So what PANGEA is focused on doing is really trying to understand with that mindset how different parts of tropical systems will respond differently to climate change and land use change. How is that going to impact differences in vulnerability and resilience in space and time across this biome? So this is a multi-scale campaign. We're thinking about identifying sites pan-tropically. One of the things that's important to emphasize here is that There's no way that even a decade of science could cover every part of the tropics. I think even with the most kind of inclusive amount of collaboration. And so ultimately, for the field components and airborne components that a campaign like this would support, we're gonna have to be targeted, and we'll come back to the super sites approach that we're taking. It is possible, though, with remote sensing, satellite remote sensing, and with modeling to do pantropical analyses. There's an opportunity to work across the tropics, foster exchange across the tropics to advance knowledge, again, of how these systems are responding in different ways and how that can inform decision-making to put these systems on more sustainable pathways. And to do that, we really do need a campaign of this magnitude to coordinate ground measurements, tower measurements, airborne, drone, and aircraft data collection so that we can make sure we are effectively utilizing these satellite data sets and improving our models to constrain that uncertainty that I just showed you. So a key aspect of this is thinking about scaling. These campaigns are really meant to improve and advance our ability to scale information that we know are more direct measurements of what's happening on the ground, all the way up to those satellites so that we can make sure we're making the most out of those data and we're actually able to infer information about what's important to us on the ground. We'll talk more tomorrow about the advances in remote sensing, but there's now spaceborne LiDAR data sets and spaceborne hyperspectral data sets that are current and forthcoming that are going to give us increasing capabilities for this type of scaling. PANGEA is necessary, though, to fill in a lot of data gaps that exist, particularly in the tropics, that are limiting our ability to scale with these data sets. So just to hit this point home again, this would really be a multi-scale campaign that would include surface, airborne, and spaceborne observations. And we're really focusing on the interdisciplinary capabilities of a campaign like this. It is housed within the terrestrial ecology program, but we really feel there's an opportunity to work across programs at NASA and across the research community to engage folks who are thinking about the ecology, the biogeochemistry, hydrology, land use change dynamics, atmospheric sciences, and other aspects of human dimensions, which you'll hear about from one of our working groups later. So what does it actually mean to scope a campaign? We have 1 year to engage the research community in this process. So our goal over the course of this year is to work with you all and many others to identify the scientific research priorities. So I gave you a big, very, very broad question. How do we turn that into feasible, tractable science questions that can be addressed by a campaign? And where there are opportunities to kind of define shared goals, again, across the research community based on existing efforts and priorities. How do we determine the geographic scope? So I mentioned that the satellite remote sensing analyses and the modeling could be done pantropically, but we're going to have to define specific locations to focus on surface measurements and airborne campaigns. So how do we start to determine that scope? We'll hear a little bit about how the PANGEA team is currently thinking about that, but it's something we're still actively developing. Feasibility is another really key component of this. So for NASA to fund this, it has to be feasible. It has to be something that can be accomplished within a 6 to 9 year campaign period. And so we're thinking a lot about feasibility in the tropics, and we have an entire working group focused on that. And we'll talk more about that tomorrow or this afternoon. I also want to emphasize that this is one of 2 scoping proposals that were funded. So Sasha Reed at the USGS and Andrew Feldman at Goddard are co-leading ARID, which is the second scoping effort. So that is a scoping effort focused on dry land systems. And I would highly encourage you, these are links. So when I share the slides online, you'll be able to click into that, or you can Google ARID scoping, Sasha, Andrew, and it'll come up. They have a website with all of their activities as well. This is an opportunity. It's kind of a once in a decade opportunity to provide input into something that could be guiding a lot of research funding in the decade to come. So I highly encourage you all to provide feedback and input in PANGEA, but also arid. It's really, really an important opportunity to have your voice be heard and be a part of that process. So both ARID and PANGEA will be delivering white papers to the program by the end of this year. So we're targeting end of November or the first week of December. We will have a draft white paper that we'll put out. I'll show you a timeline in just a minute. There's a possibility that one of these campaigns will get selected. There's also a possibility neither will get selected. There's also a possibility some aspects of both will get funded. So we're trying to really put the best ideas, the most feasible, tractable, compelling ideas into this white paper possible. And then there'll be a decision-making period where one or both or none will be selected, and we'll move forward from there. The last session, I really want to put in an emphasis on the last session on day 3. This opportunity to make the most of the scoping effort, I think, is a really important one, because we're already seeing opportunities for a lot of research ideas, potential spin-off projects and activities to emerge. You know, my hope is that this gets funded and we get to all go out and do the science and engage with the research communities in the way we're putting into the white paper. Even if it doesn't, I think there's a lot of opportunities for working together over the course of this year to develop pretty exciting ideas that could be funded in other ways. So our timeline actually started November of last year. We had a webinar, a virtual webinar. We're doing a lot of virtual activities just to make sure we hit as many folks in the community as possible. And that was kind of our kickoff. We are also doing a lot of town halls. So we had a town hall at AGU last December. I'll be at EGU next week for a town hall there. We have a lot of meetings with these different conferences and societies. If they have meetings later in the year, we're trying to do virtual webinars with those society communities earlier. In February, we actually had a workshop in Cameroon to engage with over 90 participants from the Central African research community. I'll talk more about that in a minute. This is an opportunity to engage folks who are within this kind of the ability to kind of be in the US and participate in that research community conversation. We've been lucky enough to invite a lot of folks from other parts of the world as well. And we'll have other workshops that are forthcoming. So again, before I move on to describe some of those activities in more detail, I want to emphasize that in September, we're planning to put a draft white paper out for public review. So ultimately, the white paper will be submitted November, December, but we would really like feedback on that initial draft stage. There's lots of ways you all can get involved and provide input. So just to kind of break down all these different types of activities, again, we have lots of workshops. We have lots of conference town halls and sessions that we're organizing. We're trying to get the word out across NASA programs so that, again, this is an opportunity to engage with the research community that uses these remote sensing data sets beyond just the TE program. And we are engaging with partners in a very kind of one-on-one way as well. So lots and lots of meetings to make sure we're engaging with different partner institutions. I want to highlight this meeting that we had in Cameroon at the end of February. This was, again, over 90 participants from primarily Central Africa, as well as South Africa, West Africa, East Africa. And it was incredibly well attended and very, very energizing. It was a really amazing opportunity to share this type of campaign possibility with folks from the region and get a lot of feedback. I'm going to summarize a few high level, but a lot of, I think, important high level pieces that came out of this workshop. So one, kind of thinking about the potential for a pan-tropical campaign with an emphasis on the inclusion of African tropical forests. Folks at the workshop emphasized the opportunity to build capacity. Training the next generation of scientists from that region really requires going beyond just data collection, training people all the way through to data analysis, writing manuscripts, writing grant proposals, being able to become leaders in the science. Encouraging regional collaboration. So there's a lot of silos everywhere in the world, and it's also true here in Central Africa. So encouraging collaboration across institutions and across countries. There was a lot of excitement about supporting research exchange across the tropics, so between countries in Africa, South America, and Southeast Asia. There was interest in enhancing understanding of differences and similarities between the tropics, so that's right on target with what PANGEA is aiming to do. And also a really pressing need for supporting long-term observations and monitoring in the region, which is currently severely lacking. Advancing monitoring capabilities, a lot of folks in the workshop emphasized, is a real opportunity to support things like weather risk predictions. So predictions related to drought, flooding, heat waves, as well as agricultural monitoring, carbon mapping and accounting, and biodiversity monitoring. There's increasingly a lot of data sets that are being made public that have differences, and people want support in understanding, end users want support in understanding, how do we know which one to use? How do we gauge the uncertainty associated with this? How can end users use this information? I think there's an opportunity for PANGEA to support that process. Also engaging with and reinforcing existing activities and centers of excellence. So we talked a lot about specific activities in the region that PANGEA can engage with and make sure we're aligning with. And engaging local communities. This came up a lot. So if the science is really going to be able to kind of train a new generation, there has to be engagement not only with folks who are at these academic institutions living in urban areas, but connecting back to local communities. There's an increasing rural urban flow across the world, but especially in the tropics. And thinking about facilitating the transfer of research advances to improving local livelihoods. Again, there's an opportunity in a seemingly simple but hard to do in practice way of kind of translating those research results in something that's digestible for people in these communities and translating that into local languages as well, where the research is being conducted. So a lot of really, really great ideas emerged from the workshop on that. And the participants also emphasized the need to engage with people across sectors. So again, the research community is critical to something like PANGEA, but so is government, so are students, so are different international, national, and regional institutions, NGOs, the private sector. So a lot of ideas emerged from the importance of bringing those different voices into the conversation. Okay, I want to focus here for a second on process, because I know especially folks in our working groups have started to feel a little overwhelmed with this idea of, can we do it all? We can't do it all. How are we going to start to decide what PANGEA can actually accomplish and make decisions? So as PI, the way I've envisioned this process is thinking about this as a creative problem-solving space where we start by through this divergent thinking approach. So some of you may be really familiar with this. Some of you may have never seen this. So at the beginning of thinking about solving or tackling complex problems, there's a real opportunity to just kind of think big, have blue sky approaches to getting as much information as possible. Quantity over quality matters here. New ideas emerge, creating different choices. So that's the stage we've been in. My hope is that at this workshop and over the next few weeks, we'll start to transition from this divergent, broad thinking into convergent thinking, where we start to analyze and filter all of these different amazing ideas that have come up. What are the useful ideas? What are the tractable ideas? And how can we start to make decisions? And then we'll ultimately converge on an amazing white paper that NASA is going to want to fund. So that is the approach to the process. And I just want to emphasize, I think there's a lot of folks who are excited about the opportunity to think big, and then some folks who are pretty daunted by the opportunity to think big, because it really can seem like we're trying to do it all. How do we make a decision about what PANGEA actually is going to accomplish? So we're moving into this stage now where we're going to start making decisions about what's actually going to go into the white paper. What would PANGEA actually focus on? So I pulled this directly from the solicitation because I want to emphasize a few things that are included in the solicitation for what NASA thinks a terrestrial ecology field campaign should accomplish. It is really meant to answer big science questions targeted on important regions or biomes. It's meant to enable more effective interpretation and analysis of space-based measurements, and it's meant to foster collaborative interactions and build new relationships within the scientific community. It's also meant to provide valuable opportunities for training and educating the next generation of scientists. And finally, there's a lot of examples of these past campaigns that have left a legacy of data and research activities that have continued well beyond the lifetime of that campaign. And we'll hear a little bit about that today. So I do want to mention some of the lessons that we're really kind of building on emerge from really successful campaigns that NASA has led in past years. So starting with Fife and Boreas, NASA has supported these large terrestrial ecology campaigns for decades now. We'll hear in more detail after the coffee break about LBA and above. So LBA is the large-scale biosphere-atmosphere experiment in Amazonia that was really Brazil-led. NASA got involved through 3 programs: the NASA Terrestrial Ecology, Land Cover and Land Use Change, and Hydrology programs. And then more recently, above, the Arctic Boreal Vulnerability Experiment is currently wrapping up, and that's focused on a very different biome and has been really a partnership between the US and Canada. So above, just in very brief here, I'm going to have one slide on each because we will hear more about this later. Above has similarly thought really big, although within a more narrow biome, but thinking big about causes of change, changes to ecosystems broadly. There has been a real inclusion of the human dimensions in above. So thinking about ecosystem services and social systems that are at play, that are interacting with these biotic and abiotic changes in the region. So some really interesting work. There's a lot of really interesting work that's come out of above, but I doubt this will be mentioned later, so I just want to mention it quickly. Some of the work has been looking at things like permafrost thawing and how that's going to influence things like transportation pathways, where most people in this part of the world rely on frozen earth to get around. And if that's melting, how do people then navigate and get around from one place to the next? There's a lot of kind of human dimension aspects to above, which has been really interesting to see. We'll also hear about LBA, the large-scale biosphere atmosphere experiment in Amazonia. So again, this was a Brazil-led effort that NASA got involved with through something called the LBA Eco, part of the program. And LBA was really known for advancing understanding of the Amazon as a holistic entity, kind of bringing all its component parts to understand the atmosphere, the land, the the aquatic systems, and the exchange and interaction across this entire system. It was also incredibly well known for its ability to train an entire cohort of leaders, now leaders from the region. So I'm going to steal Michael's thunder a little bit and just say quickly that over 1,000 students were trained during LBA, over 500 of which were master's and PhD students from Brazil. So that's the kind of example of success that we're looking to build on and similarly carry out through PANGEA. So we had LBA, we had a campaign in the tropics. Why do we need PANGEA? Well, LBA started 25 years ago. The world has changed and the climate has changed in really dramatic ways. We also have seen a massive advance in technology and science that is changing the way we can understand and monitor these ecosystems. We are in a data-rich era for satellite observation compared to when LBA began in the 1990s, but I'll emphasize tomorrow especially that we really need a coordinated campaign to make the most of those data. We have new data sets that were not available at the time of LBA. And again, we're still lacking the basic ground measurements to calibrate and validate and understand the potential to use those data sets. We also are starting to see evidence that tropical forests are already responding to these global changes, again, in distinct ways. And we still don't know why or how important these differences are or what that means for mitigation and adaptation. So we really do need a pan-tropical campaign, hence this push for PANGEA. I want to talk a little bit briefly about these distinct responses that we're starting to see evidence of. So this is a paper that Junji Liu led, and we'll hear from Junji tomorrow during the panel in the morning and then also during the lightning talks in the afternoon. This study used orbiting carbon observatory data, so looking at CO2 concentrations in the atmosphere, and they partitioned the source of those concentrations to the type of source. And so what they found was that in response to the 2015 El Nino event, there were really distinct causes for all of the tropics flipping from a sink to a source. So after this El Nino event, we know that in general, the tropics tend to be a system that stores more carbon than it lets out, right? But after these extreme events, like this El Nino event in 2015, that flipped. This is a very fragile region. And increasingly, we're seeing these systems go from sinks of carbon to sources of carbon. So again, this paper really emphasized that there were potentially really distinct pathways for these different continents to become sources of carbon to the atmosphere. So in the Americas, it was a drier land surface that led to dampened photosynthesis and plant growth that was the resulting CO2 emissions. In Africa, it was higher temperatures and increased respiration that resulted in increased CO2 emissions to the atmosphere. And in Asia, it was a hotter, drier land surface and fires that ultimately led to more CO2 emissions. But this actually is in some ways a bit different than the story we're seeing emerge from ground observations. So bear in mind that what I just showed you was continental scale integrated across systems that include forests, urban areas, agricultural systems. Now what you're seeing here are two examples of studies that are focused on inventory, forest inventory plot data in intact forests that are scattered across these biomes. The paper on the left emphasized differences in the multi-decadal carbon sink of the Amazon in brown and African tropical forests in blue. And so the argument from this paper was that we're seeing actually more forest mortality and kind of an increase of carbon losses in the Amazon that isn't matched by what we're seeing in Central Africa. And this could be a lag. So they're kind of deeming this an asynchronous response or change. The paper on the right was just focusing on African forest plots. And this is also just looking specifically at kind of a before and after this 2015 El Nino period. The title of this paper actually emphasizes possible resistance of these systems to change. And so the argument here is that there was a slight decline in carbon gains, but it remained gains even after the 2015 El Nino, suggesting that this system, although responding, is resistant to an El Nino event. So we have these differing stories that are making this kind of a complex system to understand. We have some studies that are suggesting that these systems are increasingly fragile, which we know to be the case, and then in these extreme event moments, flipping to being sources. And then some studies that are suggesting that actually some of these biomes, like for example, Central African tropical forests, may be more resistant or resilient to climate change. We don't know, though, if that's the case, or if that is the case, why that's the case, or if it's just a lag period. So there's still a lot of research that needs to be done to unpack what's actually going on in these systems. Luckily, we've got amazing new data from these satellite remote sensing data sets that can take us from thinking about these systems in terms of greenness to kind of the multidimensionality of these systems. Please work. There we go. The multidimensionality of these systems in ways that are more closely measuring plant level responses, for example. And so what you're seeing here is actual data that's showing information from hyperspectral imagery associated with different plant strategies on the ridge lines or in the valleys of this tropical forest in Southeast Asia. And it's hyperspectral data as well as many, many, many other data sets that are now available in this moment we're in, this data-rich era that, again, is made possible by a lot of NASA missions as well as a lot of international space agencies. So the European Space Agency is also putting many, many, many new satellites into orbit, as is the Japanese Space Agency, Indian Space Agency, and many others. So I'm going to breeze through this fairly quickly, but we're going to hear more about this tomorrow. I want to emphasize that there's now new airborne and spaceborne sensors that include spaceborne LiDAR data, so we can measure structure that directly allows us to estimate things like canopy height and above ground carbon from space. All of these data sets improve monitoring capabilities as well. So it's really important to emphasize that over the last decade, we've had advances in our ability to map global forests and measure and monitor things like forest loss and degradation. Also things like fires things that are rapidly changing in response to climate change. And then on the bottom right here is an example using planet data to map agricultural information, which is increasingly important and valuable as, again, these systems are being impacted by everything from climate change to conflicts. And the last thing I want to emphasize about these data sets is that there's a real opportunity to integrate ancillary data sets with these satellite remote sensing data sets. So this is a really nice paper that Woody Turner published many years ago now that really focuses on the ability to think about, for example, biodiversity by integrating measurements of things that we can't necessarily detect directly from space, but we can infer or proxy or relate by linking it to data sets like camera trap data, bioacoustics data, et cetera, from the ground. So we, again, are really trying to emphasize the relevance of PANGEA across programs at NASA, and we'll emphasize this throughout, but this is a big priority for PANGEA. And one thing I want to mention is the emphasis recently at NASA on Earth science to action. So this is an emphasis at NASA headquarters that's focusing on prioritizing the applied sciences. So I just want to walk through quickly what that means. So this new NASA Earth priority, which there's a lot of information about online, you're welcome to take a look, is called this Earth Science to Action Strategy. And it's focusing on the importance of Earth observations and Earth science for applied decision-making capabilities. And again, it's very interdisciplinary, and it's emphasizing approaches approaches all the way from in situ observations all the way to remote sensing, modeling, and really emphasizing the need for user engagement. Action is an interesting and important word here. We'll come back to this in our end user session tomorrow, thinking about what action means and what application and end users mean in the context of a possible campaign like PANGEA. So the definition within Earth Science to Action is thinking about accelerating the use of Earth science to support policy and decision-making for society's well-being. All of this, both the science and the action, Earth Science to Action, are grounded in this decadal survey that for anyone who's going to be involved in the writing of the white paper, we're really coming back to this constantly to make sure that this campaign would be able to speak to the priorities that are outlined in this decadal survey called Thriving on Our Changing Planet. Within the Earth Science to Action strategy, there's a real emphasis on kind of working across these so-called pillars of the pyramid to think about everything from the science and the actual research to the solutions and societal values and the public understanding of these data sets and exchanging of information. So again, we'll have an opportunity to kind of discuss what this means for PANGEA when we talk about the end user needs in our session tomorrow afternoon. The last thing I want to show here is just this example of what NASA kind of refers to when they're talking about collaboration and partnership within this Earth Science to Action framework. So it means directly engaging with these NGOs, with international organizations, with international government, as well as the public and private sector. So NASA's already pushing this, which I think PANGEA can really support. So the campaign objectives here that we're starting with, and this is really just our starting point, we're going to define a lot of these objectives and questions in the coming months as we develop the white paper. But it's to assess the feasibility and community demand for these advances through the work of this scoping study. Really trying to better understand and explain the heterogeneous tropical forest responses to change with an emphasis potentially on comparisons between the Americas and Africa. I want to emphasize that when we put in this proposal, it was initially focused on a comparison between the Americas and Africa. And the reviewers said, well, we'd like you to scope Asia too. There's a real opportunity to think pantropically. So we are doing that, and we are engaging with researchers in the community in Asia and end users. But this was the initial starting point and maybe a direction we move for something that's feasible, but we want feedback on that. We want to advance the integration of ground and remote sensing measurements, and we want to advance and improve the data model integration workflows to more adequately represent the functionally important components of tropical forest diversity that are also scalable with remote sensing. And we see this really as an opportunity to advance science capacity in otherwise underserved regions. So our overarching questions are, what are the similarities and differences between tropical regions? How are the vulnerability and resilience of these systems changing with global change? And how can this information be used to guide decision makers for climate adaptation and mitigation and biodiversity conservation? So the focus here is really thinking about biogeochemical cycles, structure, function, and biodiversity, the spatial and temporal variability of these social ecological systems, and the interaction of these systems with the atmosphere and the hydrosphere. So we've broken down science themes into biogeochemical cycles and carbon dynamics, ecosystem structure, function, and biodiversity, climate feedbacks and interactions, social ecological systems, and modeling and data synthesis. And these make up the core science themed working groups, which we'll hear from later today. And we also have cross-cutting working groups that are focusing on feasibility, community engagement, and research and applications output. One of the final things I want to mention before you all get to take a break and stop listening to me is the power of collaborative networks. So this is a really nice paper that came out from the forestplots.net community. So for those who are familiar with the forest inventory plots communities, there's ForestGeo, forestplots.net, and others. This paper emphasized the contributions of many, many, many people to the data collection that goes into this research. And so this is why you can't read those names. One highlighted in yellow is Professor Bonaventure Sonke, who's from the University of Yaoundé 1 in Cameroon and is on our leadership team. So I just wanted to try to highlight that. But the point here is that truly and I'm taking this from this paper, I highly recommend reading it. The very features that enhance tropical forest ecological values, like the remoteness, the diversity, the amount of rainfall, all of that makes field work, these surface measurements, challenging. And there's the power of these different collaborative networks that are really starting to emerge at a global scale to transform tropical science. The what we're working on, the how we're working on it, and the who is doing and leading that research. And we in the PANGEA team really want to prioritize this approach to understanding these systems. And so this is just an example of one forest inventory plot network that collects a lot of data on information at the plot scale about tree species, tree growth and mortality, these demographics and carbon dynamics, but lots of other information as well on competition and soils and plant traits. And these are the kinds of communities we're working hard to try to engage with to bring into PANGEA, because it's this approach and this information that's incredibly important to the success of PANGEA. I'm going to skip through this just to keep us moving. So coming back to this geographic scope, this is just an example of one representation of the tropics. And we are going to emphasize pan-tropical research again at the satellite remote sensing and modeling scale with PANGEA, but there's a need to figure out where coordinated ground data collection and airborne data collection would happen. So we're taking this super site approach where we are going to be identifying candidate super sites across the tropics. These would be locations that would include kind of a range of different properties. That they would include intact forests, logged and managed forests, agroecosystems, potentially even nearby urban systems to get that urban-rural flow. So there's an opportunity for input here. Ultimately, we're not going to be able to, and I don't think we should be providing a list of here's the specific sites that PANGEA will focus on, because at the end of the day, the white paper we submit is a starting point that a science definition team would then take, NASA would take, and make decisions about what's truly feasible. So we will be providing a list of possible super sites that we think are priority areas for actually addressing the science goals and other goals of PANGEA. And we're going to have, apologies to the reviewers, a long appendix of alternative or additional possible sites, super sites, recognizing that there's an important process that's going to happen after the white paper that's going to allow for really kind of coordinated and careful determination of which sites are most appropriate. So the final thing is coming back to these synergistic efforts. So this is, I think, a really important moment in time for PANGEA. There's an opportunity here to engage with a lot of pan-tropical efforts that are currently taking place. So GeoTrees, we'll hear about more tomorrow, is an effort to exchange directly between these forest plot communities or inventory and ground data collection communities with the remote sensing community, specifically with a focus on carbon. So thinking about improving the ability to calibrate, validate, put a check on what kinds of carbon maps are produced by recognizing that there's a need to support and engage with the people actually out there collecting the data. We also now have a new science panel for the Congo Basin that has been kind of co-facilitated by the science panel for the Amazon. The exchange between these two groups is a nice opportunity to kind of support and engage with scientific authorities from these regions. The related sister effort to the science panel for the Congo Basin is the Congo Basin Science Initiative, which is really focused on continuing to supporting continued investment in the scientific activities in the Congo Basin in a collaborative and coordinated way. And then One Forest Vision is led more from the European side, but thinking pan-tropically about within a really quick timescale, so kind of over the next 5 years, investing a ton in supporting research in the Americas, Africa, and Southeast Asia to advance our ability to map the carbon balance of these systems. So what we'll be doing next, and I promise this is my last slide, is working with you all and other folks over the course of the next year, the rest of this year, to determine the scientific priorities across the tropical research community, figure out what the most pressing questions are and what's feasible, again, defining and narrowing in on what the possible geographic scope should be, and identifying candidate super sites. We really want to make sure that this process is an environment that supports historically marginalized voices and researchers and communities. And again, we really want the third pillar to be focusing on guiding societal responses through these advances in monitoring capabilities. So with that, I am finished. Thank you for bearing with me, and we can head out into a coffee break in just a couple minutes, but I first want to just give folks a chance to ask questions if there are any. Keep in mind, this is the high level overview, and we'll have the next 2.5 days to really dig into this and discuss. So thank you. If there are questions, I'm happy to take them. I think people are ready for coffee. Oh, we've got one. Yes. Yeah.
Thank you.
For folks on Zoom, please do use the microphones.
Of course, thank you. Really interesting project and presentation, and thank you. I was wondering about how it's going to.
Sorry, can you please introduce yourself too, in the
Sure.
spirit of all getting to know one another?
Yeah, 1 second. My name is Rowan Kalman. I was wondering how the collaborations will work, because it sounds like you have the potential to get funding, but there's some limitations about how it can be spent. And there's a lot in the presentation that hopes for training a lot of people and doing all these on the ground connections and collaborations. So in terms of those different connections, is there any thoughts about how that might work?
Yeah, it's a really important question. So we've even put on the website the limitations to NASA funding international researchers and research. There are real limitations to that. So we've tried to be as transparent as possible about that by putting that language on the website. We're also working really hard to identify additional sources of funding that could be pulled in if this campaign gets selected. The challenging thing is that we have not been funded by NASA to do this campaign. And so it's having those starting conversations with additional funding agencies. The way we're thinking about it is through additional government agencies that have more flexibility in funding international partners and international on-the-ground research. We're also thinking about other research institutions internationally. Europe tends to have a little bit more flexibility. There's a lot of European Space Agency opportunities for collaboration and partnership, and there's other European agencies that could support that kind of work more directly. We're also thinking about donor communities. And so this is something where again, it's hard to have these conversations since we haven't been funded yet. But we really are trying to plant seeds for a lot of those and make sure the word is getting out there, and that if there is the selection of this campaign, we're doing it in such a way that would be attractive to these other funders. Yeah, landing. And if you can use the microphone.
Thank you, Elsa, for your presentation. I have one question for you. It's about ground monitoring site. I see you have a degraded area forest, you have also loggings, you have agrosystem, but I think that maybe you include it, maybe you forget it. We have specific area in which I think we need ground site monitoring. It's like protect area and also wetland, specifically for mangrove. I don't know why this site is not included in your ground truth monitoring site. Thank you.
Yeah. It's a great question. So that's also coming back to the geographic scope of this. I mean, I think wetlands, peatlands should be on there. Mangroves, I think we could put on there, and then we have to determine whether or not that's within the scope, the feasibility scope of a campaign like this. Obviously, coastal super sites could have that, but inland super sites would not necessarily have great mangroves. Although I know there's an exception in Mexico of an inland mangrove. That's a really cool example of a system. I won't get into that now. The other, so there's a lot of, there's also montane forests. Are we just focusing on lowland or montane, dry tropical forests versus wet tropical forests? Those are the kinds of things we want to hear from you all about. What are the priorities? And again, we're still in this divergent phase. So the more information we can get, the better. We will have to move into that convergent phase to start to define what's possible within the scope of PANGEA, or if there's other efforts that we're aligned with that could kind of start to make use of the knowledge we're gathering from PANGEA that could support other aligned activities. It's a good question that I don't have a great answer to. That's a great point. Dana, can you help me with that? Let's take one more question here, and then I'll maybe take 2 questions from online, and then we'll go to coffee break.
Okay, thank you. I'm Simon Tamunga. In terms of expectation or output, are there any similarities or differences between this workshop and the previous one in Cameroon? Thank you.
Yeah, great question. So we're hoping to gather as much information here that will directly go into the white paper. So what I mean by that is that we're, again, we'll have breakout sessions that are really focused on coordinating, gathering of information about everything from the science, the working group activities, end user needs and engagement, community engagement, capacity building. So all of the information from this next 2.5 days, similar to the Cameroon workshop, is really meant to work with you all to gather additional information that we'll put into the white paper. We will be summarizing that information in a report that we'll make available, and we have Google documents for all the notes that will come out of it too. So we're making all of that available to the community. Thanks, Dana.
Yeah, absolutely. So, oops, farther from my face. The first note I would say is that the interpreters kindly asked speakers to remember that they're being interpreted and remember to speak at a speed conducive to interpretation.
Okay,
I
thanks.
personally am very bad at that, so I am trying. And then there's a question here. Will the white paper have traditional proposal sections, e.g. budget, or will it just be a scientific narrative on the feasibility goals, benefits, et cetera, of a tropical NASA campaign?
Yeah, primarily the latter. We'll do some very coarse scale budgeting, but it is quite a different approach to proposing something. So actually, on our website, we have the white papers that were written about above, and then the competed tree grass proposal above was selected. So we have that to look to. We also have the LBA white paper and the Boreas white paper. So you can look to those for examples of what actually goes into these white papers, but it's not, if it gets selected, it's, again, there's this science definition team period where whatever is selected, there would be a group that would really then take that information and turn it into a science plan. My understanding is that it's at that point that a lot of the budgeting decision-making happens. So we, in thinking about feasibility, need to think about the the fiscal feasibility of a campaign. And so we are thinking about it in that sense. And I think we'll have some course numbers associated with it based on a lot of things we'll be kind of calculating or estimating, but we won't have a really detailed budget.
Great. There's another question, which someone asked, I did not see anything on tropical forests in Southeast Asia, i.e. India, Sri Lanka, Myanmar. Are the tropical forests here not part of the scoping process?
They are a part of the scoping process. And there's actually a lot of work that NASA's already doing in India. And so we're already working closely with folks who are collecting data there and working on those campaigns. I will be in Thailand to participate in a workshop that's going to be happening at the end of May to engage with the research community from Southeast Asia. I do, again, for full transparency, want to emphasize that there was an initial thought about the feasibility of this by thinking about 2 continents, so comparing the Americas and Africa. And we were asked by reviewers to scope Asia. And so we are working really hard to do that. And we are engaging with folks from that community and welcome additional input and feedback on how best to do that.
Great. There's a question, how do we promote potential super sites for consideration?
That's a good question.
Engage with your working group?
I think engaging with the working groups, so Dana, who was just speaking, is one of the co-leads for feasibility. So you could bombard Dana, but in an effort to
asking this question.
not overwhelm Dana, I think sharing that information with myself, but also I think sharing that information with working groups. If you have kind of pitches to why a potential super site would be really relevant to certain scientific aspects of the campaign, I think it is really important to engage with the science working groups and then also with the feasibility working group. So yeah, I think we'll take maybe a couple more.
Okay. Great. I would say there's one question that is in Spanish and my Spanish is poor and out of practice. So if the interpreter could, if you wouldn't mind in the chat, doing that, then we can ask that one. But in the meantime,
Dana, Alfonso is right behind you. If you can help.
Okay, that'd be great.
I'd like to know what the scope of the project is and how does it affect the regions in the Congo Basin?
We are trying to define the scope of the project. Currently we're thinking big, as I mentioned. And so we now are, and we're thinking again, pantropical for some aspects. For the super sites, we would ultimately ideally identify a range of super sites across the Americas, Africa, and Asia. And in terms of implications for the Congo Basin, we had a really successful meeting in Cameroon. And I think some of those ideas that I shared before emphasize the desires from that research community. And we can continue to explore that over the course of the next couple of days.
There's only one more. Should we just do it?
Yeah, let's do it.
What is the, what will be the representation of mountains in Pangea?
Yeah, so that comes back to Landing Manet's question about, inclusion of peatlands and mangroves and montane forests is another good question. Montane systems are hard with remote sensing data. They're hard for a lot of reasons, but they're hard with remote sensing data because of things like topographic corrections that get tricky. They are important. They're incredibly important, especially when thinking about these changes, as the opportunities for looking across elevation gradients can provide insight into potential future responses. So we are very much considering it. And my diplomatic answer, I think, is going to remain, we'd like to get information about the value of these sites and how relevant they are. And we'll ultimately have to make decisions within the kind of the feasibility conversations based on what we can and can't include. Sure.
Hi, Adia Bay. I work with NASA Goddard, and I also work with Teodil and Quinchua and Jose Fuentes and the Community Engagement and Research Applications Working Group. I just wanted to reply to one of the questions from online about proposing super sites. We've been working on a system through which anyone can propose a site, as well as suggest additional research questions. So we'll talk more about that in our update.
Thank you so much, Adia. Okay, I think, yeah, we can take one more.
Hi, yeah, David Luther from George Mason University. Just thinking in the scope of geographical representation, I know it's a small slice, but what about Australia's tropical forests too? Is
Yeah,
that inclusive?
yeah, actually,
And they could probably bring some money to the table, I bet, as well.
it's a really good point. It's a really good point. So yep, still thinking big. There is a lot of interest actually from NASA in engaging with the research community in Australia. And so we are in conversation and that's included. So yeah, I guess I should say 4 possible locations. It's a small slice of Australia, but could be important. And there could be kind of more easily available funding to support that part of it. So I guess one of the things just to mention as we kind of think big and then anticipate having to narrow, a lot of this is thinking about within the feasibility constraints about what could NASA fund, but what are other international partners already funding or want to prioritize funding. So this feasibility component is kind of a complex, moving, dynamic thing. And I think what I want to emphasize is that what we're going to try to do with the scoping paper, which is why I'm kind of dodging some of these questions, is we want to be nimble. And I think we have the capacity to be nimble in the sense that if we can focus in on really core science questions and core sites, but emphasize the ability to engage with partners depending on what opportunities emerge over the course of the coming year or years, truly, there's an opportunity to kind of expand the PANGEA mandate or community depending on what these international partners or other partners are capable of supporting. Nimble. Okay, with that, let's take a coffee break. Thank you all so much for your attention. I was going to edit a slide as well. Okay.
You do. Oh, it's my pleasure.
Hi, everyone. Let's take our seats.
Your clicker is ready, ma'am. Who's ever gonna speak, though, make sure that this gentleman? Okay, I'm gonna walk. Hey, Michael, I'm Robert. How you doing? Listen, when you use this clicker, it's right out. Yeah, kind of, and don't be afraid to really whack it.
Okay.
All right? And I'm gonna be back there if something happens.
Yeah,
Say,
I'll
I need
say,
your help."
Bob, I need your help.
Yeah,
So
and-
this is forward
Yeah, so,
and that's back.
yeah, so why don't you give it a try?
Okay. Oh, good.
All right? Put it back.
Good.
Now, did you want to try putting the lights in half, see if it's more desirable or not? And if not, just say to me, no.
Hello? Hello? Okay, good.
All right, please. Please take your seats. We're going to go ahead and get started.
Ooh, we get the low lights now. We all look more attractive in low light. It's and you know, we're talking about the past, and so you know that also the mood has changed. This session is to talk about some. Oh, okay. I'm Michael Keller. I work with the U.S. Forest Service. I'll be chairing the session, and we'll be talking about past and present NASA field campaigns to give you folks some more perspective. And the first one is the one I'll be talking about that I was very deeply associated with, the NASA contribution, NASA terrestrial ecology, hydrology, and land use and land cover change contributions to the large-scale biosphere atmosphere experiment in Amazonia. So you've seen this slide. You'll see a number of slides that Elsa and I have shared, and that's on purpose because it takes a while to absorb all of this information. So some of it is worth repeating. NASA has had this long history of field campaigns that started out with the question is, oh my God, we've got these land surface models, and how do we parameterize them? Well, we need data from the field. And I don't think I see anyone who's sitting here who is actually a Fife participant, and maybe there's somebody who was a Boreas participant. There might be a couple. But so this has been going on for a long time. And hopefully we've learned a lot from all of these experiences. We'll be talking in this session about the last two, the large-scale biosphere atmosphere experiment in Amazonia, and which the NASA contribution ran from about 1998 to 2011, and then above, which is running now. So what was the large-scale biosphere atmosphere experiment in Amazonia? The large-scale biosphere atmosphere and experiment in Amazonia, otherwise known as LBA, was a program that was conceived by the international scientific community. And it was initiated in 1998. Did the mic just, no, there we go. And it was actually led by Brazil. So we had international scientists from many countries, and under Brazilian auspices, most of the work in the large-scale biosphere atmosphere experiment in Amazonia took place in Brazil, but there was work in Ecuador, there was work in Peru, there was work in Colombia, there was work in Venezuela, and so it wasn't a one-country experiment. But the Brazilians did have a lot of trouble with the international relations side of things. And it's something that we have to keep in mind. Working with multiple countries is tough. The NASA Terrestrial Ecology Program, Land Use and Cover Change Program, sponsored a program that we called LBA Eco. NASA Hydrology and the NASA Tropical Rainfall Measurement Mission also participated in LBA. And I think it's fair to say the LBA was the largest coordinated regional scientific study that we've ever seen, still to this date. There we go, going forward. LBA put forward its own white paper, which wasn't white. It was, and it was called the LBA Concise Experimental Plan. And we did actually write the long plan too, but this is the one that everybody cites and reads. And LBA had two overarching questions. One is, how does Amazonia function as a regional entity? And that was in the Earth system perspective. What was the Earth system contribution of Amazonia? And I'm happy to see a bunch of LBA faces here, all of them older, except for mine, of course. And I'm happy to see a bunch of LBA students here too. And we'll talk more about that more than once today. And the second question was, how will changes in land use and climate affect the biological, chemical, and physical functions of Amazonia, including the sustainability of the region and the influence of Amazonia on regional and global climate? I hope that's the last time I read exactly the words off the slide, but that's a big mouthful. And, you know, here's a beautiful 1990s graphics of how, you know, LBA was conceived. And we wanted to encompass all of that. And then we learned that maybe we weren't really doing all of that, because the social scientists came knocking at our door and they said, you're forgetting the most important thing. What about the human dimension? And so the Brazilian Ministry of Science and Technology said, incorporate the human dimension into LBA. And so we had this influx of social scientists into the LBA Scientific Steering Committee, and it was really hard. I mean, it was really, really hard. But, you know, we got some of the way there and we learned some things. The NASA Terrestrial Ecology Program and the Land Use and Land Cover Change Program, they focus on the things that I highlighted there in red. The atmospheric chemistry was mainly from the point of view of sources from the ecosystem. We did have lots of atmospheric chemistry in LBA, which was mainly financed not by NASA, but by other funding sources. Now, whoops, I went one too far, I think. Nope, there we are, we're right. That didn't go. There we go. So what NASA focused on mainly was carbon cycle, nutrient cycles, land use and cover change. And in carbon cycling, where were we in 1998? Eddy covariance, which is now kind of a turnkey thing, required a platoon of specialists to run a single tower. When we started LBA, the longest running tropical tower had about 56 days of data. Okay, yeah. It was the one in Rebio Jaru, and they had extrapolated to a whole year using meteorological data, and they came up with a remarkably large carbon sink for the Amazon, which is a, you know, story that tells you it's difficult to extrapolate from a single site. There were very few long-term forest inventory data in the Amazon at that time, and what there were came mainly from operational forestry experiments. The anthropogenic disturbance that we understood at that time, or at least in terms of quantifying it, was clear-cut deforestation. But we had very little idea about how to use satellites to measure logging and how to use satellites to measure fire. And those were things that we had to take on. And as far as the regional influence of LBA goes, or of Amazonia goes, we were looking at the effects of deforestation in models and just barely starting to think about other effects. LBA knowledge of the carbon cycle started, as I said, with that one tower and 56 days of data that said the Amazon was a tremendous carbon sink. And then, of course, somebody had to publish a paper that said, no, it's carbon source. And so this graph shows data from two towers, one in a white line, one in a dark line, that actually shows carbon coming out of the forest in near Santarém, Brazil. And, if you look hard enough, you'll find everything, loss, gain, balance, everything in between, right? And not only did we, really not know the sign of where things were going, but we also didn't know the seasonality. And when we started LBA, our expectation of the seasonality was wrong. The biggest uptakes were happening in the late dry season. Then the early wet season started, and all of that leaf litter started going away and going up into the air. And so we had to learn these very basic things in order to get our models even to give us the right seasonality. On a regional scale, we didn't have satellite measurements of CO2. Okay, so we started flying airplanes, and I'll talk about this more a little later, and NASA actually contributed to a lab which exists today at INPE, which started at another Brazilian institution. It's actually moved to 3 different institutions. And Luciana Gatti has been running this since the very beginning and has published a bunch of papers, but these are from the initial results that came out of that first lab in the beginning of LBA that said, well, Amazonia, based on atmospheric CO2 measurements, could be more or less neutral in a dry year, or the biosphere part. It was actually a source in a dry year and a sink in wet years. And, this was our first big picture, integrated, Amazon-wide, atmospherically based compilation. And that's where we were at the end of the NASA contributions to LBA. So this is just giving a perspective of where we were and where we've come. And you saw this morning, Elsa showed, satellite interpretations of the, every continent. We're way further, of course. Land use and land cover change. I said at the beginning of LBA, INPE, the Brazilian Space Research Agency, was already accurately quantifying deforestation. And by the year 2000, they had gone digital, and they, to this day, produce annual deforestation estimates, which match pretty well when taking into account issues of scale with other deforestation estimates. And so we knew where deforestation was. We wanted to know where's logging, how much logging is happening, where's fire, how much fire is happening. And some of the folks who contributed to those efforts are sitting here today with us, and some of them are retired. And some of them have passed on to another future that we don't know about. The logging efforts showed us that there was as much logging going on in the Brazilian Amazon as there, in terms of area, as there was deforestation, as much as 20,000 kilometers squared per year at that time. Things change. There's about 3,000 kilometers squared of logging going on in the Brazilian Amazon in the last year. So, land use change can really move fast and change in ways that we might not have predicted. This was done using Landsat, and it was basically done, using spectral unmixing methods, which is basically about whether or not you see green or near infrared, which is our shorthand for green. And Doug Morton is here, and Doug did an interpretation with temporal filtering of greenness or near infrared to show where understory fires took place. And this is another thing that we were able to learn about through in the LBA period. And to this day, fire detection is still a big challenge. There we go. not only is fire detection a big challenge, there are people in here who know a lot more about this story than I'm going to tell. This is the Xingu region of the Amazon. It's a region that has a large indigenous territory. It also has a dry climate. 5 months a year of the 5 months of the year are very dry. It's on the border with the savannas in Brazil. It's a very diverse place culturally. It's also a place that is now burning down. And where fires were started by the indigenous inhabitants years ago and didn't spread, fires now burn for days or weeks. And this is maybe a harbinger of what we will see in the future. And it's certainly something that we need to worry about. You know, it seems that the Amazon has changed. Divino Silverio published this paper a couple years ago, and it's you know, one of the most worrisome trends that we see. American poet Robert Frost asked whether the world will end in fire or ice, and this one says fire. LBA was a monumental effort. I mean, there really were a huge number of people involved. We had counts of at least 2,000 scientists involved in LBA. Every one of them wrote a paper, right? We had at least 2,000 LBA papers. Elsa mentioned already there were over 1,000 students involved, 500 masters and PhDs, not all in Brazil, but probably the majority in Brazil. And, you know, it was a tremendous time and very, very exciting. I'll talk about the capacity building and how that all worked a little bit later today, I hope. LBA also had leaders that, you know, put their lives into the effort. Our previous terrestrial ecology saintly program manager, Diane Wickland, is there. Between Carlos Nobre and Pavel Cabat, Carlos was the overall Brazilian leader for LBA and still very active in promoting Amazon sustainability and warning of Amazon collapse. And Pavel Cabat, who was the European leader there. And this was, I think, taken in this very building at AGU a few years ago, or before AGU a few years ago. There we go. So this is another one of these slides that Elsa and I have an overlap. And LBA started 25 years ago. Now we're going on 26. The world has changed a lot in 25 years. The climate has changed a lot in 25 years. Science and technology have changed a lot in 25 years. NASA Terra launched in 1999. Okay, and now it's run out of fuel, and you know, soon it'll be in the bottom of the Pacific Ocean, I guess. But you know, it gave us a new view of the Earth, and yet now we have a much more sophisticated view of the Earth, and we have great opportunities to learn a great deal more. So when we started LBA, we asked, how are tropical forests changing? I think today we're at the point of asking, will tropical forests survive the changes? And that is one of the motivations for our PANGEA campaign. And with that, I'll conclude the LBA section and we can move on.
Before we move on, there's an opportunity. We could either ask questions here about LBA, or we could move into hearing an update from above and ask questions at the end. Do you have a preference, Michael?
No preference. I'm glad to take questions.
Okay, let's maybe take a couple of questions if we have any.
Hi, thanks so much, Michael. I'm interested in knowing just a little bit more about kind of the theory of change and how you saw that play out with LBA in terms of how the body of science developed under LBA really informed decision-making, management decisions, conservation priorities, anything along that in that kind of space as we think about the next decade and how the science we do really has to inform those kinds of things for climate and biodiversity and all of these other related crises that we're facing.
So the intent of LBA was to answer those big questions as best we could. And I think the way that LBA contributed most to policy, to environmental management was through the core of people that we trained. So if you go to Brazil today and work in the Amazon and go to state agencies and go to federal agency offices, you will find people who were trained during LBA. You will find people who were trained by people who were trained during LBA, and you will find people who were trained by people who were trained by people who were trained by LBA. You know, we've got a third generation out there already. We had, you know, this is over onto the capacity building side, but we had new graduate programs that started in what, you know, when we started our program, we're considered remote cities, remote areas. And now they have, you know, master's and PhD programs in areas related to environmental management. So I think that was the way that LBA promoted change more than any other.
Two quick questions online that are, I think, a little bit related, but one flat. Yeah, here we go. Why was LBA restricted to the Brazilian Amazon, and what was the contribution of Brazil to LBA in terms of funding?
Okay. So I guess it's not maybe my point, but I can give a historical perspective. In 1995, we had a meeting in São José dos Campos, Brazil, that brought together scientists from all of the Amazonian countries that were in the Amazon Treaty Organization. And I remember one of my colleagues walking out of a session that just involved the Brazilians and other South Americans, but no Europeans or Americans or Japanese. It was just the South Americans were there. And he said, Michael, this is maybe going to be insulting, but it's a direct quote. He says, we are the gringos now. Meaning that, you know, the Brazilians were a massive force in science compared to their neighbors. And that they were having trouble negotiating a program that would be both in Brazil and in other countries. And there's a lesson. It's difficult to work with multiple countries. It's difficult to work when there's uneven resources. So, you know, we have to be aware of that. We have to be careful about that. And LBA wasn't only in Brazil. There were projects in Venezuela, Colombia, Ecuador, Peru, but they were small and they had much less repercussion.
Well, we got a few questions.
I wanted to add something to that answer.
Okay, but funding as well.
Oh, yeah.
The Brazil contributed very substantially to funding in two ways. First of all, they provided a huge amount of in-kind support. So all of the Brazilian researchers, most of the Brazilian students who participate in LBA were paid for through Brazilian resources. And second of all, that in-kind support extended to the research facilities, laboratories, institutes, field stations, and equipment. And so it was both salaries and other contributions that were large. If we added it up in you know, dollar terms, it might look smaller, but it actually extended a huge, long way.
Peter Griffith, I was the project manager for LBA Eco. Nice to see my old friend here. So to add to both of those, to Michael's, it's very distracting seeing myself on the screen there. Yeah. With the funding, I agree totally with Michael. It is very hard to quantify the Brazilian contribution. It was very substantial. You know, it would have been impossible to do the project without all of the institutional engagement and all of those things. Back to the working, and this is part of the lesson for PANGEA. One of the reasons that NASA really focused the NASA funded work in Brazil is because doing these projects requires high level memorandum of understanding with a foreign government. And there was a huge effort to create and maintain and keep healthy the MOU with Brazil. It will be hard to do that with multiple countries as you're as you're looking at PANGEA.
That's an excellent point. And I have a deeper historical perspective than Peter, because I was there first when we got the first batch of proposals from the US investigators who participated. Not surprisingly, given the planning that had occurred mostly in Brazil, most of them proposed to work in Brazil. And it was partly the draw of the partnerships, the scientific community that was already there, the infrastructure that was already there. And, you know, it's something that we have to pay attention to as we move forward. But that was part of why things happened that way.
We have two more questions in the room, one here and then one there.
Yeah. Thank you so much, Michael. So I was very pleased when I heard about the human dimensions. And you were referring to the fact that ecological systems have been changing, right? And I'm sure human systems have also been changing a lot in the way they are integrated or not with ecosystems, in the way they are connected or disconnected from ecosystems. So I was wondering if you could speak a little bit to some of the lessons that you mentioned in the way we integrate human systems in this kind of efforts, and we make it early enough. It's not necessarily the focus of PANGEA, but how do we embed it from the start such that it's not as painful as it seems to have been for you when you did it later on? Thank you.
Yeah, I think that's you answered your own question. And it has to be built in from the start. I think it reflects where we were in the 1990s when we were, drawing those wiring diagrams. That was our worldview, right? And our worldview didn't properly include the feedbacks to human populations that existed. And so, we have to learn from that experience and, start from the ground floor. Humans and nature are not disconnected. They're intimately connected.
We have time for one more question up front here, and then just a note that we'll move into hearing about above. We'll have more time for questions after that can be related to both above and LBA.
It's Mira Hanzak, ASU. So I had actually a very similar question about social economic systems and what happened at the end to that component, and whether we are thinking actually adding that component into PANGEA.
Okay. I don't know the answer to tell you what happened at the end LBA phase one included this NASA component, included big contributions from European agencies and national agencies and European Union, European Commission. And then LBA 2 was a program of the Brazilian Ministry of Science and Technology. And LBA 2 was started with this conception of including the human dimension from the start. And then LBA 2 was not particularly well supported. So I think the intention was very good, but the outcome was that people more or less went on and did their own things with what resources they had.
In terms of PANGEA, we have a social ecological systems working group that we'll hear from later today that can speak to how we're thinking about including that. I'm going to move us on to the next part of this session. As we pull up the slides for that, I just want to share a couple comments from the chat in Zoom from folks who it sounds like were involved in LBA. So the one comment is the interaction with Brazil government was really critically facilitated by high-level scientists from Brazil to engage in that process. So that's something PANGEA would definitely depend on for researchers from different countries to be involved in that process. The second thing is somebody mentioned that LBA Eco research fed into guiding the World Bank financing of Brazil's sustainable forest management and restoration of degraded pastures programs from 2008 to 2020. So something to think about. There's a lot of real additional funding and impact that comes from these campaigns. So now I'd like to introduce Dr. Libby Larson, who will be speaking about what we have learned from the current Above campaign that's wrapping up.
Thank you very much. Yes, my name is Libby Larson, and I'm here today also with, I think actually Liz Hoy will be joining us later, and Peter Griffith, and we work along with several other people in the Carbon Cycle and Ecosystems Office at NASA Goddard, which is the support office for several of the headquarters funding programs, including terrestrial ecology. So Peter worked, as he mentioned, as the project manager for LBA Eco, and we are the support office for Above, which stands for the Arctic Boreal Vulnerability Experiment. And I'm really excited to be able to talk to you. We are really excited in thinking about, what the next field campaign will look like, how we can support it even better than we did this one. And I think there's lots of really great ideas, both science-wise, but also in how we do science, which I think is extremely important. So, right. I think you guys have seen this a few times already, but we really, wanted to think about, scaling issues and all the things that you guys are also thinking about. But we also have, this sort of the circular kind of framework for organizing our thoughts about the things, and that there are causes of change that create changes to ecosystems that influence ecosystem services that then have impact to social systems that then can drive causes of change. And this framework actually really sort of draws heavily upon the LTER, the Long-Term Ecological Research Network in the United States, for the way that they were organizing their thinking, especially 10 plus years ago when we were coming up with this idea about how we were going to do that. And we created a concise experiment plan once the science definition team was selected. Concise, again, I think maybe a little bit of a misnomer. It's more than 100 pages, but really, actually, I think that it would have been hard to make it shorter, because terrestrial ecology, even in itself, contains so many different potential topics. And so narrowing down a geographic region, talking about the importance of, permafrost or fire regime or caribou migration, or, all of these different things, we didn't want to limit ourselves to just one of those. So influencing those. And yeah, so we came up with this phasing idea that we would have a first phase where we were primarily focused on better quantifying how the ecosystem dynamics were changing, and then trying to incorporate some more of the social science perspectives and drivers, and thinking about ecosystem services from that 2014 perspective. And then this final phase, which we're moving into, which we have started now, phase 3, focusing on synthesis and analysis of, we at this point actually have kind of a backlog of data, especially airborne data, that needs to get integrated and analyzed and gotten out there. So, and this is just a quick slide that shows all of the various flights that we've done. So we have done several different summers of aircraft flights, starting in 2017 with a bunch of different kinds of instruments, and obviously having to take a break during COVID, but then getting back into it. And this year we are going to do one more L-band SAR campaign this, I think in August. And Chip Miller wrote a review of all of this back in 2019 that if you're interested in, you can find out more information about that. You know, Above, I think, has been incredibly successful on the scientific front. We have, you know, more than 500 publications by 157 projects. I can go way more into this later if you're interested, but we had sort of had this idea that we were going to have, you know, sort of the core funded projects that were funded by the TE program or related programs at NASA. But then we were also interested in having affiliated projects, especially, say, from our Canadian colleagues who could not receive money from NASA to do the work, but we wanted to be able to sort of collaborate and train with a bunch of people. So we have these sort of like affiliated projects. We also had partners, say, with NG Arctic. Polar is a Canadian federal agency, Canadian Forest Service, NEON, et cetera. So what that has meant is that the science team has gotten quite large. So we have over 1,000 members. That's if you include all of the, you know, the PIs and co-Is and students and postdocs and all that other stuff. And then another sort of 2,000, you know, well, not another, but a total 2,000 people who are, you know, interested in being on our list and hearing about updates about what's going on and everything. So it's been really great to, I think, invest in and grow this community and make those connections. Let's see. It was decided early on that the above data would be stored at the ORNL DAC. And so this is just a list of some of the different types of data sets and the number of those that we have available at the DAC. As a side note, just thinking about from a planning perspective, you'll notice that, like, in the middle figure there where it has the above domain, there's actually 2 outlines. There's a red and a purple. And I think that at the time we were honing in on the red, but then some people were like, well, we want to include the Boreas sites that are a little bit further south, and maybe we want to go all the way over to Hudson Bay. And so we, you know, we had like an extended domain that we said, well, that will count as being part of above if there's really sort of some projects motivated to work in that area. But while it felt really meaningful at the time that we were making that distinction, I don't know that that's really kind of ever played in further to a lot of the work that we've ended up doing in our focus. So let's see. So in thinking about the lessons learned for this, the science is really important, but the success, I think, of these types of campaigns, obviously it depends on doing good science, but I also think that it's extremely important to think about the structures and processes. And I think that this is a really exciting time in science, just in general, because I feel like scientists and the scientific community as a whole are thinking a lot more critically and self-critically about how it is that we do science. Why do we do science? What do we do science for? And that the sort of older models of, loading dock, like I'm just going to write my paper and get it published in a journal and assume that some land manager or something is going to find it and pick it up there and use it, really doesn't apply and doesn't really work, and probably never worked super well to begin with. So I think that there are many different categories of that it's useful to think about ways that we can set up structures and processes that make the science really impactful and successful. So, first thinking about data development and sharing. One of the things that Above did early on, there was a geospatial working group that got together and decided that they were going to develop pick one projection and develop a grid for that, and that was going to be the official Above projection and grid. And so in the data products that were produced, everybody would use this. And so it would be able to facilitate data interoperability and reduce the time for individual projects for if they're accessing data that's already been produced, not having to, reproject everything, et cetera. And it also helped, I think, with easy having a data archive. So I don't know if that's something you all have thought about, but this is definitely something to consider. And then something that I think has changed quite a lot, especially in the past few years, that quite frankly was not quite at the forefront of our mind when we were planning Above initially. Like, we knew we wanted to have partners with Canadian federal agencies and other research institutions, but I don't think we thought very explicitly about ways that we could be in good relations with all of the important and relevant communities that we really needed to. And I think this is especially important for thinking about how do we do equitable and just and anti-colonial science, especially since we're quite literally a flyover research institution. So that, I think, is a difficult thing to engage with, but we have lots of different sort of articles that we've been collecting over time. This is a particular one that I really enjoyed that was in PNAS, thinking about what are the various components that are required for being in good relations with the people that you're working with and the communities that you are collaborating with and engaging with and everything. And we could have a whole sort of long conversation about that. I've been super excited to hear about all of the ways that PANGEA has already been thinking about these kinds of things. We spent a bunch of time sort of thinking about ways that we could support the science team and the science team itself kind of organizing around different thematic working groups. Those working groups changed over time depending on particular needs. So, there were some that were more active earlier on and others that have been really ramping up with synthesis activities now. So and some of them have been, thematic in terms of like carbon cycle, but then there also have been, like a spectral working group that is just kind of working together, regardless of whatever the research question is underneath that, but to understand the data that the aircraft are collecting. And we also have, I think, and we talked about the success of LBA Eco in this, but I think it's really important to think about the ways in which a field campaign like this can be especially important for supporting early career scientists. And so making sure to include them as co-leads of working groups, being part of scientific meeting planning committees, serving as moderators, all kinds of ways that they can start to be more fully engaged in the broader scientific community, I think is especially important. We've talked a lot about already the importance of partners to success. These are just some of the logos of various partners that Above has had. And I think that, you know, we have built some really strong relationships in this space, but I also think it's an area where we could have had improvement. And, but it's been hard because not being able to fund people at a non-US institution, I think has really quite hampered our ability to do work in this area. And you would think, well, you know, Canada is, you know, comparatively quite a rich country. And so how, you know, why aren't they sort of stepping up and matching or doing, you know, similar things? And we have just kind of had really varied success in getting the Canadian partners, and they've had their own kind of political issues going on, et cetera, so that like there's, you know, there've been groups that we've worked really well with, but then there hasn't been like, say, an overarching federal sort of effort on the Canadian side, I feel like, to really kind of match what we were doing. And so we've been working hard to like keep them all engaged, but I personally see it as a challenge. One of the things that has been relatively, this is just, you know, example of a code of conduct that we use for our meetings. When we first started above, having a code of conduct at a meeting was not a thing that anybody ever talked about. And now it's actually a NASA requirement. If you have a meeting, you have to have a code of conduct. And I think that that's especially important to continue and preserve and evolve over time. And Peter especially has done a lot of work thinking about creating safe and inclusive work environments, especially for field work. This is a snapshot from our website where, in addition to having a bunch of, you know, safety videos that you can watch and information about how to get permits and logistic support, Peter was also involved in organizing an interactive series through AGU Biogeosciences about safe and inclusive field work that I think is especially valuable and something that we continue to think about. And then, you know, from our perspective, especially as we're nearing the end of above, I think that the science communication part is, you know, just getting bigger and bigger. And, you know, Peter had sent in these suggestions about the fact that the NASA Office of Communication staff have been really excellent partners for us for, you know, creating these types of news stories, and the Science Visualization Studio, you know, can also create some really amazing things. So there's like this nice, like flashy NASA stuff that can happen, but I also think that like, I'm personally still sort of figuring out like, how is it that we're, you know, we're at the end now, we have all these amazing scientific research products rather, and I feel like there's a kind of big logjam of, you know, getting that information out there beyond just the sort of niche scientific community, and you know, working with you know, decision makers and other potential end users, and you know, finding the best path for that. I think will be interesting to see how that evolves. And I think that from my perspective, a lesson learned is like, if we could have thought about those things a little bit earlier and maybe been more strategic for doing that, I think we could be in an even better position than we are right now. So so yeah, I think that there's been a lot of change and in the way that we do science, as I said. So even though Arctic boreal stuff is not at all scientifically related to the stuff that you guys are talking about, I think that there's still some important things to think about with respect to doing a field campaign. And that's it.
Okay, we have about 15 minutes for questions before we break for lunch, and be glad to entertain above questions and LBA questions. So let's start with some above related questions, and then circle back to LBA for this time.
Well, it's actually both above and LBA. Hi, Ian McCubbin from JPL. Is involved in both LBA and above. And I would ask Michael, or Woody's not sitting next to me, but I see Ken, has anybody checked in with Diane Wickland? Because the impact of Diane Wickland on these programs, going back to Fife, Boreas, I think is notable and worth
emphasizing. So I just think it would be good to reach out also to show the diverse audience we have here and the impacts that her long-term investments made. And I just want to acknowledge how important she was to LBA. And we learned a lot from LBA and how she kind of passed on. Peter's saying yes over there. So Peter, I'm going to
Text when I sent her a text when Michael
Okay.
put up the picture with her. So, well, she hasn't responded yet.
This is Jose Fuentes from Penn State University. I have a question about the above projects. Both Canada and Alaska have large communities of Indigenous people. Can you share with us how you were able to engage the Native communities? I am more particularly interested in the Alaskan communities because those are, part of our underrepresented groups.
Yes. To be quite frank, at the project level, at the science team level, we haven't done a lot of engagement with Alaska Native groups, and in large part have relied on the individual projects building their own relationships through their funded work. And from my perspective, part of that is a little bit about a question of scale, right? And I think part of the thing that's always been somewhat of a tension is thinking about, okay, we have a whole bunch of individual research projects. Then what can we do as a team, right? And so there are a lot of different Alaska Native groups, and figuring out, should we try and contact all of them in the region that we're working with? And if so, if we don't have anybody actually say on the ground doing work there, then are we putting a burden on them by making them engage with us for, like, what is it that we can offer them? It's also can be, I was just learning actually a few weeks ago, we were at the NSF Navigating the New Arctic team meeting, and I was just learning there, for example, that like in each community, there are actually 3 different Alaska Native entities that you should really be interacting with. And so not just the tribal council, but the corporation. And I'm forgetting now what I have to go back and look at my notes. So I feel like Alaska has been a place where we could have done better at the science team level. In Canada, it's been a fair bit different, in part because in order to even do our aircraft sorties, we had to get permits from the territories, and in some cases even permits from Indigenous groups or First Nations there. And so that meant that kind of necessity, we had to be doing some engagement. And there have been varying levels of interaction and interest, and especially I think capacity on the side of different First Nations wanting to be engaged in that process or not. Peter has had some great interactions in the Northwest Territories, and has been invited to the Satu Dene, some of the work that they've been doing in their terrestrial biosphere reserve kind of stuff. So in that case, like I said, it was sort of because we had this like structural impetus to like make us do it. It made us do that. And I think that that's a huge lesson moving forward, is that I really want us to do it because it's the right thing to do, and not because we have to do it to like get a permit to do something. And so I'm hopeful that moving forward, we can be even more appropriately engaged with Indigenous groups.
Yeah, thank you. Doug Morton, NASA Goddard. I wanted to just ask a question. Libby, was prompted by your last response and something on your slides. It's for both of you though, for Michael as well. I guess based on the successes and your view in the rearview mirror of these 2 very large scale campaigns, kind of wanted to focus in on sort of what is the level of emergent properties that will happen just naturally because people will get together and talk about similar things. And how would you think about recommending a structure that would maximize the synergy across groups, because I think there have been elements that have been very successful in that context. There's also been, as you point out, Libby, disparate projects. And so I think in the planning and the focus, where would you provide your feedback on how to maximize the success of a campaign like PANGEA?
Whoa, that's hard. That's hard. Well, one of the things I didn't talk about was after the concise experiment plan, then we had the implementation plan, which I think when we first wrote it, we thought, okay, you know, we got that done. That's where I think that's where we saw the phasing diagram that I showed came from the implementation plan. And in looking at our website now and looking at that, and I can see that we actually had to update that and change it over time. And part of that was, of course, due to COVID and blah, blah, blah. But like I said, part of it was the ways in which both the science itself was changing and the way that we do science is changing. And so I liked hearing Elsa talk about, you know, trying to be nimble even at this early stage. I think it's important, say, after, you know, if PANGEA gets selected and funded, to still think about ways to be nimble in the, you know, sort of organization and engagement with each other. And so I don't have a sort of specific idea of like, well, if you just organize, you know, your thematic working groups this way, it's going to be perfect, because I think that of necessity, it will change over time, and that's probably a good thing. So my hope is that I think that what having a team means is that hopefully it's not just sort of one person's decision about kind of like what's important and what gets addressed. And so really kind of focusing on that team decision-making process, I think is part of what will set you all in the right direction. I don't know if that's the kind of thing you were looking for, Doug. I wish I had a great answer for you, but.
Have another comment, two comments. And, you know, one of them is that we, more than we have done in the past, we have the capacity to model first. This, you know, we learned a lot about bucket plots, and we also, to some extent, know where our gaps are. So we point out through models and observing system exercises where we need to look further. The second one is to borrow from our colleague Martha, who's sitting next to you, is that essentially we're all modelers. You know, the card carrying time that spent most of their time having code, we're actually writing data sets. You know, but the card carrying time did everybody else. And they, you know, the thing that Mark has done in his mind and work.
Yeah. Is this microphone working better for the interpreters?
Is this better? Okay.
They're working for us. We just want to make sure they're working for Zoom
Oh,
participants and the interpreters.
Is this okay? All right. So the second thing is that, you know, when Marcos put together his model and data synthesis working group, he didn't just put together a group of card carrying modelers, so to speak. That is a diverse group. And that's also very important as we get going. So I think those are my two replies to your question.
Okay, let's hear quickly from Peter, and then we have one final question, and then we'll break for lunch.
So in addition to those, the other thing that from that the phases of above, in addition to the modeling being first, the stakeholder engagement should be first. We have this in above, you know, 10 years ago, we were thinking about, oh, we'll talk to stakeholders about the data products in phase 3. And that's not the way to do it. So the carbon monitoring system is a better model where the project comes in with identified stakeholders with an iterative process of working on the data products from the get-go. And I think that whatever happens next should be more like what CMS does than what Above did.
Denny?
Yes. Okay, thank you. I'm Denis Janson-Waf for CIFOR, Center for International Forestry Research. In the above program, in the above, you mentioned the member and participant. I was asking myself, what is the difference between those who were member and then those who were participant? And then another question that I have is, when you mention, I would say, the good relation in action, which is something which is very nice. And then when we see that, we generally think between interaction between scientists and then maybe the others. But my question is, within the scientific community, sometimes you may have certain type of asymmetry between group of scientists. I'm really asking the way you think we could anticipate in such a way that we manage those type of asymmetry in the, I would say, in the better way, in such a way that we have a very coherent, I would say, program. And then lastly, I think for the LBA, we mentioned the fact that we started with a lot of emphasis on biophysical activity, and then later on integrated the human dimension. And then now I'm asking myself, at the end of that, is it possible to have some sort of the framework that really allowed to have a good designing of the experimental design when we want to start a new initiative? Because I imagine that from the beginning, the theory and then the framework were really more biophysics, but now we really want to have, I would say, the human and then the ecology scientists be working together, but we probably need to have some sort of a good framework that will really help from the beginning to anticipate the type of design that we need to have in place.
Okay, so yes, so the we have a distinction in above between above projects and then affiliated projects, and part of that was recognizing that there were lots of different individuals and also groups and organizations and agencies that were already doing quite a lot of work in the region, and we wanted to you know, have a broader community feel and engagement and interaction beyond just the NASA funded projects. So so we were tracking saying, okay, well, we have, through the terrestrial ecology program, this number of projects that were funded, but then we also had the ability to say, well, if a researcher at Wilfrid Laurier University, who's funded by NSERC, which is basically the Canadian equivalent of NSF, right, had something that was, directly relevant to the work that we were doing, we would include them as an affiliated project so that they would have the benefit of, being able to engage and interact with the science team. In some cases, we were also able then to be able to get them access to a lot of the data products, especially the commercial data products, if they were partnering with someone at a US institution, et cetera. But the reason that we still didn't just count them as automatically being a part of above was because we wanted to not just kind of take over everything, right, and count everything as being a NASA thing, excuse me, even if it wasn't. So that was just a way for us to think about how we were going to engage with the science community, even if they were not funded by above, basically is the short answer for that. And I think that that a little bit feeds into your question about good relations. And you're right, the slide that I showed was in large part focused on good relations with the communities in which you are working. But I agree, it's very important to think about good relations within project and the science team as well, and to be explicit about thinking about inequalities and differences in power, for example, that might sometimes need to be explicitly addressed in group dynamics. And while the slide that I had, was focused on ways to support early career scientists, I mean, I think that it's good to sort of think explicitly about, say, when you're having a planning a science meeting, being sure that you have, representation from all of the sort of different groups and relevant communities within the science community for that. So that I think was the above stuff. And then
the question that you posed regarding LBA, I think you answered, which was, we can't fix the problem in the middle of the program very easily. So, you have to fix the problems before you start the program. And, we are faced with some structural challenges. The program that we're directing our scoping plan to is the NASA terrestrial ecology program, right? And so how do we conceptualize the human dimension and how it portion of at least the NASA terrestrial ecology scoping plan when NASA terrestrial ecology is not specifically a program to support human dimensions research? So that's a a sort of meta question right now. And the world is going to be divided into boxes some way or another, and it's hard to do everything everywhere all the time. And so how are we going to do this? First, yes, but how? I don't know.
Maybe I could take a stab at that.
Sometimes one has to be humble.
So we're going to break for lunch in just a minute, but I do want to emphasize that I think there's a lot of groups that are increasingly recognizing the need to do interdisciplinary research. And there's, whether it's from LBA or other research efforts, there's good examples and frameworks to start from and to draw from. And the understanding that we're working within a complex Earth system that's integrated, I think was a big part of LBA. We're trying to do the same thing, but even in a more kind of holistic way. And that's why we're talking to all different programs at NASA that have potential interests and thinking about that quite deeply. I want to move us into lunch now. So just an announcement, we'll be back in here at 1:30. The working group co-leads, let's meet in the lobby. Actually, sorry, let's meet on the terrace upstairs. We'll get some fresh air. So co-leads, Emily, can you raise your hand? Emily in the back has offered to give folks badge access on the elevators. So if you're in a co-lead, if you are a working group co-lead, grab your lunch and please head to the elevators to go upstairs for lunch. We'll be meeting. Everyone else, please take some time to enjoy, have conversations, and we'll meet back here at 1:30. Thanks. Okay, please have a seat. We're gonna start the afternoon sessions. It's now my pleasure to introduce Professor Bonaventure Sonke from the University of Yaoundé in Cameroon, who will be chairing our session our first session this afternoon on working group updates. I think as the working group leads come up and present in a few minutes after we hear an introduction, please feel free to stay up and take a seat at the panel. We'll pull more chairs up if needed, because we'll have a Q&A session at the end very, very, very briefly before we move into breakout groups. I'll let Professor Sonke take it away.
Thank you. Thank you, Elsa. Hello, everyone. Let us go back to this session. Many people talk this morning, and we have to start brainstorming about what are we going to put in our project. So this afternoon, we are going to review the scientific question of what are we going to do and update the working group. And then after that, we are going to break into the group. We are going to think about the similarity between and the differences between tropical region. And also, we are going to think about how the vulnerability and the resilience of tropical forest ecosystem are involved in changing the global changes, and how can this information, we can use it to give it to the decision maker. So we are going to focus on 5 questions. The role of the tropical forest in the biogeochemical cycle, and the tropical forest structure, function, and biodiversity. This might be the second question. And the third one will be the spatial and temporal variability of tropical forests. And then what the interaction between ecosystem with the atmosphere and hydrosphere. If we want to answer those questions, we can stay the whole group and then deal with that. So the idea is to break into the group, and we think we'll have 7 groups, right? So the first group will deal with the biogeochemical cycle and carbon dynamics. The second one will deal with ecosystem structure, function, and biodiversity. The third one, climate feedback and interaction. The next one will be socio-ecological system, the modeling and data synthesis. We are trying to have this project fund, but we can't do everything. So we have to think about, can we do what we are proposing? So we need to have one group thinking about the feasibility of what we want to propose to NASA to fund. And the last group will be the community engagement and the research and application art group. So this is what we are going to do this afternoon. After this session break group, we are going to come back here. We have 60 minutes, right, for discussion. And then when you come back here, we have 20 minutes for report. So what is going to happen is, in each group, we need one person to report and someone to lead the group. Yes. So may I ask? Sarah.
Thank you very much. I'm Lily Slakutika. So it's okay? Yeah. Yeah. This one. So we are co-leading this group with Michel. You can see Michael, Lebien, and Patrick. And you can see we have 27 participants. We started quite late, but I think we could succeed to make a group to get something we're going to present to you. Yeah. So the motivation of the group. Tropical forests are hotspots of carbon dioxide and methane cycling, and small changes in the balance between sinks and source can have large consequences on climate. So what is the scope? We need to identify the pools, meaning where is the carbon now, but also to understand controls on fluxes, where are they going? So as I said, we have a 27 member on the email list. However, we are thinking about expanding our group via Google Forms. We now have, with the help of Isaac, 75 more potential member. And we also hope at the end we will have more people who are going to be involved in these groups. So once we establish smaller groups, working groups, we personally will involve folks to participate, so we could fill gaps and according to expertise. So our meeting was, we succeeded to have 5 meetings, as I said, although we started only, the first meeting was in March, yeah. And the level of engagement was 11 to 60 members at each meeting. We didn't break on the smaller group like other groups. We just have one meeting where we could have all the people regarding time zone. And for that, we could have, that's going to be the last, we could have a working group. We first make, according on the base of the question of PANGEA, what are the similarities and differences within and between tropical regions? How are the vulnerability and the resilience of tropical forest ecosystem changing with global change? We could make the working document where we have been working. I can make like that, no? Yeah, okay. So you also have Jamboard on which everyone was coming, putting some question. We have a working document we could make on Google Drive, so each of us could have put his input. And for that, and we have 2 tables where we have similarity, differences, and which we get, we could build following our meetings. 4 days work we did so far, and which is available on Google. We could make some research, 6 groups of questions. My colleague Michel are going to present you further, and I will, at the end, I will again make some recommendation. So Michel, we have a lead.
Yeah, so obviously biogeochemical cycling and carbon dynamics is quite broad, and we really iterated on trying to identify the largest knowledge gaps, the most compelling scientific questions. And then to iterate, we basically wanted to create subgroups of questions that we could start to identify like where we're missing expertise gaps, because so far we have some members that are presenting, but we don't actually know if we're encompassing every single interesting question. And so there's different axes in how we can organize those questions, like by subregion or by biome or by the type of biogeochemical cycling. So we would really love feedback on these 6 groups. And then I think once we kind of maybe hone in on those kind of subcategories, we can start to interface with other working groups as well. So I'll go into and then 2 of the largest questions that kept coming up in a lot of our working group meetings were really about acclimation, adaptation, and tipping points. So this is probably a cross-cutting question across all of these groups.
And then the other is we want to seek maybe a geographer that can help us with quantitative representation of the different ecoregions. Like when we're thinking about an IPCC approach to kind of combining carbon fluxes and stocks. So we want to like know the distribution of montane versus flooded versus monodominant forests. And then also the relative data density across those regions. So maybe there's some other organizing folks or the data feasibility team are thinking about this. So the first theme was tropical forest resilience and vulnerability to climate and land use change. And so we kind of grouped these questions into two categories. One was on tree mortality and the other is soil carbon. And so one example is, does the extent, length, and type of water, wind stress, or heat stress matter? Because we know that there's large knowledge gaps in what climate events actually drive tree mortality and how we can actually get like more small scale meteorological data to help us understand drivers of tree mortality. Questions about historical variability if that helps with tree resistance to mortality, and then also questions about how we can start to use remote sensing products to help identify like biochemical or physical traits that maybe could indicate more vulnerable species. And there's been some work, I think some papers published on forest health and remote sensing. The other category is soil carbon, and I think that we had a lot of discussion on if this is within the scope of a NASA campaign because we can't really decompose autotrophic respiration from soil respiration fluxes. But if we're doing some on-the-ground data, then there's maybe some ability to start thinking about above and below ground dynamics and how they influence soil carbon. And then also, I mean, we know that soil carbon is strongly controlled by mineralogy, so I don't know if that's within the scope of NASA, but questions for you all. The next question that we identified was on the role of nutrients in controlling tropical forest productivity. And this is a really, really broad question. So within the scope of PANGEA, we did try to narrow this down a little bit into asking which tropical forest regions are the most vulnerable to nutrient losses, what types of land use change are going to drive those variations in nutrient losses, and then and that could help us indicate which regions to target for maybe like nitrogen limitation or versus calcium limitation or phosphorus limitation. And then we have a little schematic here of maybe some potential feasibility is to really pair airborne imaging spectroscopy data with in situ canopy nutrients. So if we do some tree climbing, maybe we can collect some canopy leaves to measure for nutrients. And then if there's any capability of going to spaceborne, we have no idea. So question for you all. The next thing, we actually decomposed like demography and productivity away from carbon losses from tree mortality. So one of the big questions is, what are the roles of animals and biodiversity in maintaining seed dispersal? And so we really identified fragmented forests and heavily hunted forests as more vulnerable regions that maybe some of these questions might, we might be able to entangle some of the mechanisms of animals and dispersing seeds. And the other question that we identified within productivity is that a lot of our data actually comes from short-term studies. So a lot of like leaf, seedling, small scale tree studies. But there's actually a big gap in between that knowledge from the small scale studies to long-term adaptation. So maybe with like Amazon face, this is going to help us a little bit with scaling from small leaf scale to forest scale. Questions in response to different global change drivers like elevated CO2, nitrogen deposition, warming. The fourth theme was, and this maybe overlaps with the climate group, so excited to hear what they have to say, but how are hydrologic and biogeochemical cycles linked, and how do they vary across different tropical regions? And so one example we have here is from the Amazon basin, where we have quite a bit of, we have way more flux tower data in the central Amazon and eastern Amazon. And the western Amazon, we also see divergence in models in precipitation. And so but we don't have as much on the ground data. So, and then we know that there's also linked hydrological cycles across the basin that we just don't really have on the ground data for. And then also questions about how warming and increasing CO2 are going to affect stomatal conductance, then downstream precipitation, and then eventually carbon dynamics. And then also questions about drought tolerant species and how they interact with soil fertility, because we know that there's potentially a role in potassium, for example, in affecting species resistance. And then our second to last theme is on wetland dynamics. And we did identify wetlands as a specific biome of interest because they have really large carbon stocks and are potentially very vulnerable. So asking how changing hydro periods and land use change might affect carbon sink source behavior, and then also nutrient transport across flooded and wetland forests. And I think this is a nice example of where we can maybe start to think about pairing structural data from LiDAR with getting water height data from SWOT perhaps, with in situ gauges to measure on the ground fluxes. And then also asking how sensitive wetlands are to global change drivers. So we know that peatlands are really vulnerable to fire. And then we also don't really know a lot about long-term peatland carbon accumulation too. But maybe that's outside of the scope of this campaign. And then the last theme, shout out to Paulo. Someone commented that we didn't have fire in our questions, so then we added fire last minute. But asking what are the impacts of tropical forest peatland fires on the Earth system? So asking about VOC, aerosol emissions, and cloud condensation nuclei, because that's really going to affect downstream climate conditions that are going to affect productivity. And then another question that Paolo highlighted was, what are the net emissions of fire on carbon cycling? So parsing out immediate combustion versus later decomposition versus regrowth. And then also some, I guess, breaking down CO2 emissions from abiotic methane emissions from fire as well. And
just for some recommendation and step and next step. So in our group, we think that we cannot say that it's too broad or too specific, but we need definitely, last time, you know, that we are just saying that we could include Australia. We definitely need some people from tropical Asia, because it's very important. And we hope after this meeting, maybe things will move forward. So which topics of our group should have further engagement with other working groups? I think Michelle says something about climate group, but it's not only. And what recommendation we can say? We say that we are starting, you start to make the table I told you about, and to list out another tools which could help with another folk to move forward on this aspect. And also we need help with the quantitative geography of eco-region and data representation across this region. So also, how can we interact with and minimize overlaps with other working groups? We are talking about that this lunch when you have a meeting with other lead groups. Also, climate feedbacks and interaction, structure, function, and biodiversity modeling. We know that we have Cesar in one of our meetings, and we hope after this DC meeting, we'll have more involvement with other groups to see how we can move forward to avoid overlaps and to also to be more efficient, I think. So we have our idea how we break on these 6 groups Michelle talked you about, but we are also open to see maybe there are other ways to try to make representation and to have the term how to move forward. I think tomorrow we're going to have another meeting with lead groups, and that will help us to move forward. Thank you.
As the next group is coming up, please just a reminder, do we have co-leads? Yeah. Just a reminder to everyone speaking into the microphone, presenting or asking questions. I'm saying this as much for myself as everyone else. Speak slowly so the interpreters can translate. Thank you.
Okay. Hi, everyone. I'm Helena Miller-Lando. I'm one of the co-leads of the Ecosystem Structure, Function, and Diversity Group. One of the other ones is over there. Mateus, you want to stand up quickly for people who don't know? Mateus Nunez. And then also helping with the group leadership is Fabian Schneider, who's our contact with the executive committee, and Libyan Sagang, who's the early career co-lead. Do I just click this to go forward? No, wrong one. Okay. So starting with the kind of working group motivation and scope, the idea of the motivation for having a working group on structure, function, and diversity is that tropical forests vary widely in their ecosystem structure, function, and diversity. And this variation is important. It influences responses to global change and other anthropogenic influences, among other things. Pantropical patterns in these variables and the mechanisms underlying these patterns remain poorly understood overall and poorly represented in terrestrial biosphere models. So while there's certainly been, oh, slow down. Okay, I only have 7 slides, so I can slow down. Sorry about that. This is something I'm organizing a meeting in June where they're going to have simultaneous translation. I was like, don't even think about doing it for the lightning talks. It's not going to work. But for this, I can slow down. We should have had the slides translated, huh? There's been a lot of progress, obviously, in work on these patterns, but still they remain poorly understood overall and poorly represented in models, limiting our capacity to accurately predict their future trajectories under global change. So for those of us working in tropical forests, this new generation of remote sensing seems to offer an amazing opportunity to quantify variation in tropical forest structure, function, and diversity over space and time, and thereby contribute to major improvements in understanding and modeling of tropical forest. In particular, as has been mentioned by others, LiDAR and imaging spectroscopy enable mapping of canopy structure and plant functional composition across the tropics, and thus the potential to identify important axes of variation. And further kind of linking with the modeling, improved understanding of plant trade-offs and associated axes of variation among plant species related to nutrient acquisition, drought tolerance, fire tolerance, and so forth, is critical to improving modeling of tropical forests, including responses to drought, fire, storm severity and frequency, and climate variation. Oops, wrong one again. So the working group process, when we started out this process I think we started in February, at that point, the Google Doc that had kind of people who had volunteered to be involved in the group had 84 people. And the last time I looked on last Wednesday, it had 189 people. So not everyone who's on that volunteer list was on our early emails because they weren't on that list yet. So we've been meeting, the leadership has been meeting every 1 to 2 weeks, and we've had several kind of larger group meetings that invited people from that larger set of interest groups. And we've also invited people to fill out Google Forms to provide input on questions. And within the meetings, we've used Google Jamboards, breakout groups, and some whole group discussions to get input. Oh, one again. Oops, wait. Oh, this doesn't include the slide I added. Sec. Can I? All right. So this is the version from Friday. It's not the one I put in the folder this morning. Okay. Yeah, I thought Isaac sent me the wrong. That's what I was just showing you. Okay, so I had a slide in there with the people, the names of the people who've contributed so far. So we've had, I counted it up earlier, 52 people have contributed so far to the working group, either by coming to meetings or by filling out forms. And so we're very grateful for that engagement from the community, and we're hoping to get even more input from more people going forward. So from that engagement, are some preliminary findings on big questions, which kind of echo what was in the scoping study report, is that one obviously is to understand what are these patterns of variation across the tropics, across all the regions in tropical forest ecosystem structure, function, and diversity. And importantly, what are the mechanisms underlying these patterns of variation? So of course, remote sensing should be able to get the patterns once we figure out how to interpret the data. But you know, that in and of itself doesn't get us to the mechanisms. And then the other big kind of overarching set of questions which we group together here is how is ongoing global change altering, and how will it continue to alter tropical forest ecosystem structure, function, and diversity? And what are the mechanisms underlying these changes? And we kind of combine this, obviously, the brainstorming Google Jamboards and so forth, and the Google Doc that put together had a gazillion individual questions that involve tipping points and feedbacks and the role of compositional shifts, but it kind of all fits back under, you know, these two general questions. Yeah, I'm apparently still not very good at this. Oh, there we go. There we go. Oh, I see. Got it. So in terms of knowledge gaps, there were also some kind of general patterns when we took all that brainstorming and kind of said, okay, how do we group that in together again? We kind of came into these 4 categories. So one is uncertainty about the generality of patterns and knowledge based on the currently available ground-based data. And a key issue there, which has been brought up already, is that the ground-based data are patchy and they're biased in their distribution, reflecting biases and where research has been done in the past. A second big point is incomplete understanding of patterns of variation among tropical plant species in their functional traits, their environmental responses, and contributions to ecosystem structure and function. Again, linked to the limited empirical data. And especially if you look at some trait-based databases and you look at tropical species, you're like, oh, there's data for a lot of tropical species. But then if you zoom in a little more, it's concentrated in relatively few places. So that limits our ability to appropriately represent tropical diversity in models. A third is the role of plant species composition in driving forest structure and function. So especially maybe from the temperate or such perspective around a global scale, we often think of structure and function as following from climate and so forth, with species composition just being this sort of intermediate part of that mechanism. But for the tropics, with the different biogeographic regions, there's a lot of prior knowledge and evidence that plant species composition itself is really important in forest structure and function, even after controlling for climate. And so that's important to understand geographic variation today and for considering global change responses going forward. And then a fourth major set of knowledge gaps is the limitations of current remote sensing capabilities for tropical forests. So there's great promise, but the basis for that remote sensing interpretation for a lot of variables is not yet solid, both due to relatively limited ground data for calibration and validation, and due to novel sensors that are not yet well related to ground-based observations, including, of course, future sensors. So this is my last slide. So our preliminary in thinking about the role of PANGEA and talking about this and getting input from people, the many ideas that kind of were raised kind of fell again into these few categories. So one is just having a really well-designed, well-distributed ground-based and airborne sampling strategy that's well-distributed with respect to forest types and regions, fills geographic gaps, and informs regarding geographic variation. Also an integrated set of co-located measurements. So this gets at the supersite idea. Basically that it's better not just to have like traits here and ground-based plots there and airborne data there, but having that all together so that we can get more out of those measurements. More data on functional traits, again, across multiple sites and more than just the commonly measured, easily measured few traits. So looking also at, say, forest architecture and things like, and roots and more. Then also incorporating forest function from tower-based instruments. And another thing that had a lot of interest in the group was kind of being able to link spaceborne pixels to plant taxonomic ID and plant traits by actually having crown maps of local sites. And there was also a lot of interest, even though we recognize PANGEA is only 6 to 9 years, but this gets at something else I said earlier in having long-term data sets. And so having this be potentially the start of multi-year time series of data. Another key role of PANGEA would, of course, be to determine and improve the remote sensing capabilities and calibration. So improve the basis for calibration and evaluation of remote sensing products and develop new tools for monitoring tropical forests from space, especially for the biodiversity values and for ecosystem variables and for ecosystem function variables. Another big set of questions or kind of aims or role was under improvements in understanding and modeling of tropical forests. So specifically including better understanding of plant diversity and improved representation of plant variation or diversity in models, better quantification of geographical variation and better reproduction of these patterns and models, and better ability to scale up from ground-based measurements. And finally, something that came up as important, which crosses over to some other working groups, is the importance of building on the ground capacity to collect the necessary ground data, which involves not just purchasing equipment, but also training and capacity building within sites. And I think that's it for our group. Oh, sorry. Oh, no, I was wrong. This is the last slide. So recommendations and next steps. So at this point, we felt like what we're really ready for, and it's great to be here at this meeting to be able to move this forward more, is coordination, communication with other groups. On the modeling side, what traits, data types are most useful in improving understanding of mechanisms and the representation in models. On the feasibility side, what are the constraints on potential ground-based and airborne data collection? What role can drones play? And then talking with the other groups, I know when I looked at this set of groups at the start, I was like, well, there's carbon dynamics and ecosystem structure and function. Aren't those kind of like overlapping? So basically getting together and hearing about these other groups and what our commonalities and differences are and what we see as knowledge gaps and recommendations. I have wondered if we should be aiming to produce a traceability matrix specifically for the structure, function, and diversity metric questions, and if we can even do that. Do we know enough to do that? And on the question we were asked to address, is your working group topic too broad or too specific? I'd say it's been good for this previous stage, but I'm wondering whether we're wondering, I should say, it's not just me, whether we should reorganize as we move to making research plans. For example, taking people from multiple groups and saying, okay, we're going to need to do plant traits and strategies, measurements, what traits, what strategies, how, where, or things like that. So I think that's it. And I'd like to once again thank everyone who's participated and contributed to these groups and to our group. And I hope we'll get a chance to get input from more of the people here and also online in the future. Thank you.
Hello, everyone. I'm Robinson Lebron Juarez from the Lawrence Berkeley Lab. I'm co-leading the Climate Feedback and Interaction Working Group. Our colleagues are Julie, he's a faculty at UCLA. Sarah, who is finishing her PhD and moving to JPL. Xiaoming Xiao. Xiaoming? There you go. Xiaoming. And he's University of Oklahoma. And Junji Liu, she's a JPL. The laser, okay, okay. Yay. Our scope, I want to summarize this. Our scope is a cross-continental initiative to understand climate feedbacks and interaction in tropical forest. Our goal is, our goal of our working group is to identify scientific gaps in climate feedback and interactions can be addressed using field observation and remote sensing and use that science, the new science, to improve models. Our working group meets every week. Currently, we have 105 participants. We have 2 main meetings. Each of these meetings, they have in different time zones to attend everyone. And then we use Google Forms and all Google capabilities to keep us in touch. From these 105 participants, all of them, they fill our form and they give us ideas about what should be doing. And here I'm going to summarize the main topic. So from all these 105 participants, giving us different ideas, we selected the 5 more relevant topics. Actually, Sarah is the person who did that. The first topic is biochemical cycles. And then the question is how do droughts or too much rain affect the carbon and methane fluxes in wetlands? And here's a good one. How can we quantify tipping points? Yeah, that was a good one. And then how can we quantify changes in plant functional traits? The second topic was ecohydrology. And here, a key question was how do current changes, for instance, CO2, fertilization, drought, etc., affect the carbon and water cycles? The next one was very interesting. Are there hydrological thresholds? And if there are the same across tropical forests? The third topic was climate disturbance and forest dynamics. And here, the main question was, how do disturbance and their effects differ across continents? And the second question was, do the disturbance produce a cascade effects? The fourth topic was soil microbiota and climate change. And the main question here was, how can we produce healthy soils? And basically, of course, we need to understand how that works. And the second question was, how do land use and climate variation impact nutrient cycle? The last topic was about land use change. And the main question was, how do the patterns and drivers of deforestation differ across continents? And the next question is, how do the land use affect the weather? Or preliminary findings, it was unanimous. For instance, people suggest that in areas where we don't have observations, or it's very challenging to do field observations, which NASA could fly aircraft to have measurements. A second point was collaboration with past projects. There is LBA, 10 years of data. We should leverage all the data. There is Tropics, etc. And to have a better understanding how the tropics are working. Of course, combine in situ data and remote sensing. That is obvious. And explore the links between biochemical cycles, forest dynamics, and the nutrients, and how they affect the plant functional traits. Or recommendations and next steps. You can read that then, but I want to mention something very interesting. We noticed from all those 5 topics, scientists from different regions have different point of view. And was kind of at least for me, when in one of our meetings we see a large participants from Africa, and they do prefer to speak in French, and we just we wouldn't be able to communicate. And every region have a different point of view, and very clear actually. That means we are missing a very important input from people from Africa. Okay, that's it. Thank you.
Our next presenter is online. I'll be advancing the slides. Marius, can you try speaking?
Yes, here I am.
Amazing. Hopefully this will work. Great. Okay. Just let me know when you would like to advance your slides.
We'll do that. First of all, I have to mention that, of course, just right now, construction started, so I hope it's not too distracting. If it is, please let me know, and we'll figure something out with Hannah potentially covering for me. So hopefully it's not too bad.
So far, so good.
Okay, great. Hi, my name is Marius von Essen. I'm one of the co-leads alongside Maria Santos and Alencar and Hannah Stouter of the Social Ecological Systems Working Group. And next slide. And this is the agenda for our presentation today. We'll stick with the overview and a process update. And then we'll talk a little bit about how we think about the definition of SES, of social ecological systems in the context of PANGEA, and then go over some knowledge gaps and the potential outcomes related to social ecological systems that could come out of PANGEA, and then have a couple of next steps also. Next slide. I wanted to start here with some quotes from the PANGEA proposal, actually, and those acted as starting points of our working group. A topical terrestrial ecology campaign has the potential to reveal trade-offs and synergies between land use practices, ecosystem services, terrestrial geochemical cycles, and biodiversity, and variables to address within the SES science theme revolve around deforestation, degradation, agricultural expansion and productivity, urbanization, secondary forest dynamics, fire radiative power, and burnt area. Next slide, please. And then here we highlighted some terms that stood out to us that we think are central to the idea of social ecological systems. And yeah, you can actually advance twice now, Elsa. And that is that these processes, responses, and practices that we highlighted here are carried out and shaped by human actions and human systems. And understanding these proximate and distant drivers of the physical change that we see on the ground requires approaches that are complementary to the remote sensing that will be done as part of the PANGEA campaign. And those will include social, cultural, economic, and political perspectives. And that's kind of what the content of the working group will focus on. And we'll get to that quickly after I'll go over our process slide, which is the next one. So we have roughly 80 people in the sign-up sheet, of which I would say 40 have participated in at least in one meeting. And actually you can just advance like 3 times now, Elsa. Yeah. We had a meeting frequency with an all-hands group of around every 2 weeks for a total of 3 meetings. And then we followed that up with a co-lead meeting, so also every 2 weeks for a total of 3 meetings. So we had 6 meetings in total. And we felt that when we had the meetings, people were actually very engaged and we had very productive conversations. What didn't quite work as well for us just yet was the asynchronous participation, for which we used Google Forms, and those in total yielded less than 5 responses. So we try to maybe improve that a little bit, but it has been a little bit slow. One thing that we started to implement, which already has been quite helpful, was to record the audio and then use use a AI software tool to create transcripts. So we actually have full transcripts of the meetings, which we can then dive a little deeper into to kind of go back to what people have said verbatim. And I think that's been quite helpful already. So we're planning on continuing doing that. Our approach to scoping the topics of the social ecological work group has been that the co-leads identified broad themes, and then those themes we opened up for discussion during our all-hands meetings. And then each of the all-hands meetings was dedicated to a specific theme, for example, around the definition of social ecological systems and what the knowledge and research gaps are and how we want to move those forward. And at this point, I'm going to hand it over to Hannah, who will talk a little bit more about how we think about defining social ecological systems. So yeah, next slide.
Yeah, so this was the first all hands working group meeting we had, was really focused on this idea of what is a social ecological system. The proposal outlines what a kind of what a social ecological system might look like, but we instantly kind of got feedback, and I think among working group co-leads also felt like this didn't fully capture all the ways in which social ecological systems might function. So can you click ahead? So we wanted to kind of take what was in the proposal that Marius presented and get feedback on it, and what the feedback we really got really pointed to this fact that what we really need to emphasize are the feedbacks and the interactions that exist between people, the environment, and the climate, and take a really like systems-wide approach to this to understand both the distal and the proximate forces that are shaping social ecological systems. And in addition to focusing on things like land use change and deforestation and degradation, working group members brought up things like governance and policy and economic systems and indigenous communities that they felt really should be included in a social ecological systems approach. Next slide, please. And so taking all this feedback, what we've come up with is this redefinition that really takes this systems approach and centers the idea that there are these feedbacks between people and the environment, and that what PANGEA needs to focus on is those feedbacks. And in doing so, it will be able to then uncover kind of how social, political, and economic systems, both what are in the tropics, but also globally, and how they're interacting to shape ecosystem functions, land use practices, biodiversity, and biogeochemical cycles, all these things that the other groups are bringing up, and how they're being shaped by social and economic forces. Next slide. And so with that, after kind of we built off of this definition, we started to identify kind of key knowledge gaps, and these break up into kind of more thematic knowledge gaps and then more methodological knowledge gaps. So we started with kind of this idea that there are these diverse knowledge systems that when we're thinking about something like social ecological systems need to be included. And there's a strong push to really make sure we're including indigenous and local knowledge systems. And so building off some of the work that especially the community engagement group is working on is important when we're understanding both the social dynamics and the ecological dynamics. Similarly to thinking about local livelihoods, looking at sustainable development, so bringing in things like social economic well-being, food security, and public health into how we're thinking about these ecosystems. A third factor that came up quite a lot was governance, specifically how certain government or policy or market dynamics might impact ecological outcomes. So thinking about those interactions. And then this is a social ecological working group. So what we're really interested in terms of this fourth knowledge gap is how ecosystem function is being impacted by social systems. So thinking about ecosystem services and biodiversity conservation, carbon cycles, all of those things. And then we move into these more kind of methodological knowledge gaps. So this idea of socializing the pixel or pixelizing the social, how can we use remote sensing data and combine it with more economic and social measures to better understand what's happening within social ecological systems? And then how can we use that to inform some of the more modeling efforts that are being taken place to understand how tropical systems are being impacted by global change? And then across all of this, thinking about the links between what's happening at a local scale and the global forces that are shaping those things. So the kind of feedbacks and telecoupling that exist within these systems. Next slide, please.
That would be me, but there's literally a jackhammer going off right next to me. I don't know if that's
Zoom is amazing. We can't hear it. So
okay.
you're good to
That's
go.
unbelievable. That's unbelievable. Yeah. This is a diagram. It might be a little overwhelming, so I'm going to kind of break it down and get through it. So we think of social ecological system as having this like hourglass shape, and on the one hand, we have the social system with the subsystems, and on the other, we have the ecological system with the subsystems. And on the right, we included climate change as like an external variable that will impact social systems and ecological systems both at the same time. And then on the left hand, we included the scale to just show, at least for the social systems, that a lot of these processes, that drivers happen at a global level all the way through the local level and have impact at the local level as well. In the center of the hourglass, we find this nexus, these three round circles, and those spell out nature's contributions to people. They have local communities in there and forest condition. And these three subsystems interact with.
It is getting a little hard to hear you. Yeah, I think we'll maybe hand it back to Hannah.
Sorry.
No, that's okay.
I'm terribly sorry. Sorry.
So Hannah, if you want to jump in and finish off the slides, and I'm going to give you the 30-second mark too.
Okay. Yeah, so as Marius was saying, at the center, we have these three: nature's contributions to people, forest condition, and local communities. And we see those things as kind of all interacting at the and interacting at the interface of kind of social systems and ecological systems. And then there are all these factors that are underlying that impact how these things impact land use change, or on the other side, kind of ecological function, structure, and diversity. Next slide. Marius, did you want to try again, or should I keep going?
Just go ahead, Hannah.
So in terms of breaking out those in the center of that circle, when we look at something like forest condition, you can think about something like, you can break that into how this is impacting forest condition in terms of deforestation, degradation, and regrowth. And then in terms of the social ecological feedbacks, we're really trying to point to how those things, what remote sensing measurements we can use to understand how they're changing, and then how they're being impacted kind of between these nature contributions in local communities, but also further out. So something like deforestation might be impacted by agriculture or fire in terms of degradation, and then what we can use to measure them and look at these interactions. Next slide. And can you advance this 2 more times? 1 more time? Yeah. And then so really kind of looking at this more broadly, we highlighted kind of specific remote sensing data sets that we could use to get patterns of land use change or look at burned area estimates, and then integrating them with political and economic data and also field data And thinking about how we can bring these two things together to really get a better understanding of not only where deforestation, something like deforestation is happening, how forest condition is changing, but also why, what are the underlying drivers. And then in terms of next steps,
Sorry.
no, that's fine. Really kind of figuring out how to bring together creating these two roles where we'll have both active participants who participate regularly in kind of these bi-weekly meetings, and figuring out better ways to really get more passive input, especially since we're seeing that the forum isn't yielding a ton of responses, but we want to make sure people broadly can participate. And then really linking the work that we're doing with the other working groups to start to dig into more deeply into these knowledge gaps, especially now that we've really started to define a framework within which we want to work.
Thank you. Okay.
Hello, everyone. My name is Marcos Longo. I'm from Berkeley Lab, and our working group is a combination of 5 co-leads. Antonio Ferraz, who is also here in the room, and Cesar Tejera, who is also in the room, if you mind like raising their hands and saying hi. Also, Felician Munir and Yanlei Feng, who are our early career leads, maybe online, I don't know, I can't say anyone. So the main goals of these working groups are, we can think about 3 major goals. One is to identify scientific knowledge gaps that could benefit from improved modeling or data synthesis, and especially when leveraging remote sensing. Also, to determine novel ways in which we can integrate field and remote sensing data sets in a way to reduce uncertainties in process-based models in data synthesis efforts. And finally, try to establish opportunities for the existing models and data synthesis approaches to help answering questions across the different science themes of Pangea. Our group, working group process has been first to identify people that could help us to achieve these goals. And we contacted nearly 150 people. About half of them showed interest at some point. By the way, if anyone here would be interested and haven't replied to us, or if you haven't reached to you, do reach us out to us. We are still interested in getting more people participating, because even though like 75 showed interest, about 25 people, maximum 30 in few cases, but sometimes as low as 10 people attended the meetings. One important thing to highlight is that we did not only invited people that are directly working with model and data synthesis approaches, and that's because we didn't want to have a bunch of people just talking about the theoretical part without having any input from the reality of actually making the measurements. In any case, our meeting frequency, we have been meeting weekly amongst the co-leads, just to develop the strategies on how we are going to carry out this meetings with the broader group. And we also have been meeting weekly with the broader working group, trying to alternate between time zones. So people across different time zones could actually participate at least once every other week. And we've been also trying to attend other working group meetings to make sure that we are not having like completely detached discussions through the other science themes. I would say that the engagement has varied quite a bit. And we noticed that like we get more feedback from people when we have smaller working group, breakout groups within our all hands meetings. And we've noticed that there is quite a lot of engagement when we have more interactive tools like Jamboard, although it's always impossible to tell with Jamboard if it's like everyone is participating or it's just one person that is super enthusiastic putting posts every time. Like, so there is that question. We did, like the socio-ecological systems group mentioned, we had very limited feedback from Google Forms, but I would say that even though they were very sparse, some of them were really great points. So maybe it's worth engaging on that. Slack, we have been using a lot for the leadership, but much less with the broader group. Maybe something for us to explore in the future. Let's see. Right. So our approach to scoping the topics have been to first identify questions across the science teams that could leverage modeling and data synthesis techniques. And we also had some limited discussion. It's something I think that Michael alluded earlier today on using models and data synthesis approach to identify where we have the greatest uncertainty, and maybe that can be used to prioritize the choice of sites. But we haven't done a lot of this. And I have no idea what happened with the format here of the presentation. But anyway, our approach has been like first to start broad and start identifying questions that people are generally interested in, and then start to rank on what we think it's the impact going to be, and then select more specific questions within these broad topics that we could explore more and discuss the data and model needs to answer those questions, identify what measurements we would need to have, and then have like the fun discussion about what's actually possible to do, and then identify which questions are going to be viable within PANGEA. So kind of like thinking in the science and applications traceability matrix, maybe not like so following so closely, but like with that general idea. And here, just to highlight a few knowledge gaps that we identified, maybe for interest of time, I'm not going to go one by one here. But just to highlight that within our group, we actually have been addressing questions that may be related to all the other science teams that we have discussed, that we have heard in the session today. And also like to highlight that some of those questions have this very strong connection between the science team groups. So like just to highlight one, for example, the climate extremes, changes in disturbance regime, and shifts in environmental forcing may affect ecosystem functioning, ecosystem resilience to tipping points, which I have heard several times. And it brings together not just the climate feedbacks, but also ecosystem structure, also some social ecological systems. So just to highlight that those questions have been a bit multidimensional. So I'm starting to get the timing warnings here. So maybe just to quickly wrap up. So some of the needs that we identified is land use history. I think we need more data across different gradients of land use history, or measurements across different forest structures. Also, better representation of soils, which seems to be an important area of uncertainty that many participants highlighted. And also like models that account for multiple dimensions of anthropogenic activities. We also identified some questions in terms of strategy, like how we are going to define spatial units for analysis, how we are going to integrate across this analysis. And also like there has been some discussion about like, should we only focus on supersites, or we should have a bit more sites across with less measurements. And okay, and just like another thing, I am aware. Another thing like that came is like, how can we use models as a way to integrate as an integrator of PANGEA, and also like how can PANGEA help us to fill some gaps of observations. So just like for next steps, there is one thing that we've noticed and other science teams noted is that there is a huge risk of like not having enough overlap with the other discussions in other science teams. So there must be a very strong integration between our group and the other groups. And one thing that we did not focus so much is like how the general, how to go from general questions to questions that would be more like intercontinental or within continent driven questions, and increase participation of across different countries, meaning different time zones, without overburdening the co-leads. Also, like our group, we think that our group is a bit too broad, because we are a group focusing on methods and approaches, as opposed to okay, 2 more bullet points on a run from here. So for us, this is an important thing to think at this point, because our group is very broad and it's a tool to answer scientific questions. Is this group actually a group that needs to exist, Or maybe that's an opportunity to make a group that it's the interdisciplinary group for Pangea, but then the question is, are we the right group to do this? Also, like just like as a recommendation, it's just like to figure out ways in which you can exchange the results and discussions across the working groups. And this is how let the others.
Like a valiant attempt to be very fast. But exactly. It's tricky. It's a tricky balance. Hi, I am one of the co-leads of the feasibility working group. Ian McCubbin over here is another co-lead. My name is Dana Chadwick. I'm at NASA JPL, a scientist in the Water and Ecosystems group. I would point out that I am absolutely taking my co-leads names in vain here because these slides were developed very quickly. And so this is a kind of very dynamic group. So this is for a lot of consideration and feedback that we'd be interested in. This is fairly early stage for feasibility. So I will preface with those thoughts. This is the description from Elsa's written document about what our working group is supposed to do. So I figured that would be appropriate to put here with the kind of highlighting that we're supposed to engage across all science theme working groups. So this is intended to be a cross-cutting group to work on this feasibility establishment. We are, I would say, are on the slower side to get started. We've led 2 remote meetings, one in March and one in April, to kind of begin the discussions here. And then Mark Samard also led a feasibility meeting at the Cameroon workshop that sounds like was very successful as well. Level of engagement. This is not an easily translatable phrase, so I would say small to medium. I think there's not a lot of not a lot of necessarily understanding about where we are and how feasibility fits into where we are at this exact moment yet. So we're gonna, this is part of the thing that's really nice for us, I think, about being here, is starting to really get a better understanding of where the other working groups are. And I'm going to echo Mark's thoughts and many of our other working group thoughts as well about the need to begin to kind of start to do more overlap and better understanding between the groups. So, but I think this is a perfectly timed community workshop for that exercise. So I think that most of our effort so far has been trying to kind of scope the boundaries of what feasibility is, because it can get too broad too quickly. We cannot scope every site where people have taken data across tropical biomes. And so thinking about how do we kind of strategize. So instead of preliminary results, I just wanted to kind of highlight a little bit of preliminary information that we've started to gather. So this is work that Fabian Schneider did at the outset of Pangea to kind of aggregate data that NASA has collected across the tropics, and that is along with some other in situ sites. And the kind of important thing to highlight here is that NASA does operate in the tropics. So this isn't like not feasible out of the gates. So this is, and we're going to start adding to this as we know AFRISAR is going to be deploying across a lot of the African continent in the coming months. We've also been getting great input from other folks. Stuart Davies, thank you for this, about kind of the locations of some of these large plot networks and thinking about how those are going to be potentially integrated into the work that we're doing. But this, I would say, is an ongoing data collection effort. And I think that there's going to be a lot of input that we're going to get from this community around particular sites that are of great interest. And I'm really excited to be hearing more from the community engagement group, because I know they've been starting to think about how to start gathering the types of information inputs people are interested in providing. So I'm hoping that we can synergize with them on how to move some of those things forward as well. So so I'm going to just come back here and highlight, we'll engage with all science theme working groups. So I buried the lead here, but yes, we're excited to be at this meeting because I think this is a really useful thing for us to start to engage with and have a better understanding of where the science is going within the community. And we cannot attend, unfortunately, all of the meetings that all of the other working groups are holding. So trying to figure out how we're going to kind of do that give and take effectively. So these were also the prompts. So our working group, I think initially it was kind of feeling too broad. We of course cannot scope every potential super site. And then based on some feedback from our fearless leader, we're thinking about the idea of really doing more to define process at this stage. So once Pangea is selected, manifest, right? Having a really clear outline for how the science scoping activity will continue, because there's generally a phase there where there's additional kind of scoping efforts. And so thinking about, did other people lose audio? Oh, okay, all right, I will continue on. So thinking about really more constructing a framework of how feasibility can be determined, because depending on when planes get in the air or boots get on the ground, the geopolitical realities could be very different. And so some of that feasibility, we don't want to have to redo feasibility a variety of different times. So, thinking about then applying that process to several sites, I think would be really valuable. And then we were also talking about the fact that some of these science applications traceability matrix type efforts could be really valuable to us. It's very much of a NASA centric kind of way of thinking about outlining a project, but it could help with the feasibility team dramatically to understand, as we are making these assessments at a later date, okay, how many sites do we need along this type of gradient to answer this set of questions? And at what point are we not going to be able to address these particular questions anymore because we lose feasibility on that? So these are things that I think we're going to continue to talk about, but it's been, I think it's been interesting to kind of work through this in a variety of ways. These were just some potential example super sites for assessment that have had some prior NASA activity in them. These are absolutely up for discussion. I'm not saying that this is what we're doing for sure, but, just kind of giving you an example, and we would want to include a Southeast Asian site as well as one of these. So, but that's ongoing discussions. And I think we would really like to work with kind of both all of the working groups and the community engagement group to think about how we could better facilitate the working groups providing us with the information that we need to determine feasibility for sites that you in particular work at. You all are the experts and have the most deep knowledge about the sites and that you engage with. And so it does not make sense for us to be reinventing the wheel here. And so somebody earlier asked about, how do I get a super site in for consideration? And this is something that we want to be starting to build, is how do we gather enough objective information about different sites that we can kind of, consider these criteria thoughtfully as we move forward. And with that, did I nail the time? Yes.
Hi, everyone. Gonna start my timer. I'm Adia Bay. I work with NASA Goddard, and I've been working with Jose Fuentes from Penn State and with Teodil Nkuinchua to co-lead this working group. Do you guys just want to wave your hands? Okay. So we started out as two separate working groups, one on community engagement and one on research applications and outputs, but we decided to merge them because the topics are very closely related in order to understand how we can serve communities and provide useful outputs. We needed to engage with them. So we decided to work together. We started with the text that's in the Pangea proposal about what these two working groups are about. So we want to ensure Pangea's research meaningfully engages communities and also benefits stakeholders. We want to define necessary processes, applications, and outputs. And we want to plan how to collaboratively and effectively work to sort of achieve the goals of PANGEA. I should say this isn't the latest version of the slide, so I'm going to have to improvise a little bit. But yeah, it's just sort of touching upon some of the bits that other groups mentioned. There are around 80 people who've expressed an interest in participating in our working group. And of those, I'd say around 24, 25 people have participated in our last 2 meetings. We've had meetings every week over the past 6 weeks, and half of those have been with the co-leads and half of them have been with a broader working group. I'm going to touch upon this key pillars of success. Maybe I can go forward and then go backwards. Okay. So we've structured things a bit differently. It's a cross-cutting theme. So we haven't used like bodies of research as a point of departure. We've been looking not only at knowledge gaps, but also methodological gaps and procedural gaps as a point of departure. So we've structured our framing, our scoping. We've been framing our scoping around sort of a who, what, where, when, why, how kind of framework. Thinking about who should we be engaging with, who should we be collaborating with, what are we going to do? What are we going to do to scope? What are we proposing to be a part of the implementation? Where are we going to scope, and where might PANGEA be implemented? When, like, how much should we be doing now in the scoping part? What can be achieved in 6 to 9 years during implementation? Why are we doing this? What's the broader purpose? How are we going to get this done within the next 5 months in terms of contributing to the white paper, and then also within the next, within 6 to 9 years, how can we achieve these goals and actually have something that's meaningful and impactful? And then outputs, what specific things can we produce now? And what can we produce longer term? I'm gonna try to go back, even though sorry. Oh. So starting with the why, in the latest version of these slides, we have a slide about why. Our goals are equitable collaboration with communities, with diverse communities, and co-creation of the research agenda, knowledge, and research outputs. And then we also want to think about the legacy. Even though we're just starting, we want to think about the legacy now. So not just so that we achieve something within 6 to 9 years, but so that when the funding ends, positive things continue to happen as a result of this project. Oh gosh, sorry. Why is here? And so, yeah, there is some research available that sort of explains why we are, working the way that we're working, why these are our goals. And one of them, and this relates to some of the things that people have mentioned, if we want to have long-term data sets and monitor ecological changes long-term and advance remote sensing with ground-based, by integrating some ground-based data, we need to build that off of profound connection with forest and with disadvantaged communities. And we need to base this in long-term relationships instead of sort of parachute science. Who, what, where, how, and outputs. We've been working on 4 different things. One is a community engagement database, which I'll say more about all of these things. The regional workshops, which I actually won't say more about because Elsa and others have, about these. This is one of them. And then the third is virtual workshops with specific communities. And the fourth is 2 research papers that will involve surveys and semi-structured interviews. Okay, so this community engagement database, it is a web form which feeds into a CSV file and then feeds into a map. The idea is that people map things for all sorts of reasons. We would like to map our potential partners to understand who's working where, who already has effective relationships on the ground with communities. It may be indigenous communities, maybe it's an academic community, youth groups, women's groups, companies, so on and so forth. So we envision having a database where anyone can propose to be a potential partner. And when they do that, they would explain the type of partner they are, and how they would like to engage in PANGEA. So they can engage by proposing a site, by requesting capacity building, by offering data or requesting data, or offering to collaborate on capacity building, so on and so forth. In the form, you can enter spatial data of where the partner is based, where the partner works, alongside programmatic info. And then this is just a sneak peek of the map. And the idea is that this would be a filter, sort of an interactive map where we could all potentially use this database. We could see, well, who's working, who could benefit from this data, who can we collaborate with. We want it started with thinking about who can we engage with, but the idea, we'd also like it to be a tool that facilitates South-South collaborations and avoiding sort of reinventing the wheel, finding synergies, but also sometimes doing a gap analysis and, you know, maybe adding a flux tower someplace where there already isn't one, things like that. How regional workshops, we've done 2 virtual workshops, or we just did a women's workshop with Cameroon participants, and we plan to do another one with indigenous groups in Panama. I put third to be determined. We're open to doing more. So if you'd like to kind of propose one, just let us know. And then the last piece is we plan to do 2 research papers that will work on getting published in peer-reviewed journals. One is focused on community engagement in tropical forest research. So this is led by Isaac. I'm sure everybody knows who you are, but Isaac and Hannah and others at UCLA and others from the working group are participating in this. And the second is a global assessment of effectiveness of technical capacity building. So this would be basically done with people in the working group in collaboration with, of course, NASA, but also the Food and Agriculture Organization. This is my last slide. And so 5 ways to support our working group efforts. It's not too late to join us. You can start attending our working group meetings. You can add potential partners. You could start by adding yourself to this engagement database, but you can also propose new partners to it. Right now it's sort of a prototype, so you can help by providing feedback. If any of you all are really good at web mapping and want to help with that, we don't yet have all of the functionality sorted yet. And yeah, so, okay. If you want to help with that, you can help with that. You can also organize a virtual workshop by engaging an underrepresented community. Or you could help us with interviews in English, Spanish, French, Portuguese, or some indigenous language to help us have new voices, incorporate that into our scoping process. So if you have any questions or if you want to get involved, can maybe everyone who's been working with our working group, can you just raise your hand? You can talk to one of these people or me, but please talk to them since they're probably sitting very close to you. Thanks.
For those presentations, so we have to bring into the group, and we have the first group going, is going to stay here, right? The second group also is going to stay here. The group working on climate feedback, going to main floor is where?
So yeah, so now we're moving into breakout sessions where we can actually start having conversations with these working group co-leads. So we're going to have about 60 minutes. This will move into our coffee break. And there's time for open discussion and providing feedback and input. So the coffee break, after the coffee break, we'll meet back here at 4 p.m. But all of these rooms, there's plenary side A and B for the first 2 working groups. Out in the lobby, the main floor here will be the climate feedbacks and interactions working group. If you go outside here, there's stairs that take you downstairs. There's another lobby area down there. That will be the social ecological systems working group. And can I have the person are you going to be leading the in-person? So we have, can you just maybe introduce yourself briefly, because our SES working group co-leads are remote. They will be participating remotely. But we have an amazing volunteer to lead the in-person discussion.
Hi, I'm Shivani. So yeah, I'll be leading that working group. Yeah.
Thank you. And then the modeling, and there's 3 conference rooms downstairs. So if you see that lobby area, there's 3 conference rooms down there. The first one, Clouds Room, will be modeling and data synthesis. The feasibility group will be discussing in the Blue Marble Room, and the community engagement and research applications group will be in the 3rd Rock Room. A disclaimer for those of you on Zoom or for anyone in the room who is dependent on translation, we are unfortunately limited to translation just in this plenary room. So if you are in need of translation, yeah, Adia? Except in the community engagement, we have French and Spanish. And maybe if somebody who speaks Portuguese and English wants to participate in the community engagement, we could have Portuguese translation as well. There are people in the room who, in fact, if you were able, you might have put the languages you speak in the information that Isaac shared. So some folks here are multilingual. I'd encourage you to engage in translation in the working groups that are not in here. So with that, you all are free to self-select into a working group that is of most interest to you to continue the discussion. And we'll meet back here at 4. Coffee will be out and available to keep those ideas flowing at 3:30. Thanks.
Please be sure that you have someone to report when you come back here in each group.
Yes.
And each group will have 2 minutes for report, not more than, please.
Yeah, good point. So they'll find a note taker, take notes, and after the coffee break, we'll hear 2-minute reports from what was discussed.
I'm not sure if anybody can hear me, but I have no idea how to join a working group online.
I think a lot of us have the same questions. I guess I was just waiting to see if anybody answered on the meeting chat, but no, they're not.
No, normally you get sent to a meeting room if
Right.
you're online, but
it looks
I
like
think it
it's
just
there
popped
now.
up.
Yep.
It's up now. Thanks, everybody.
did we get an answer?
Yeah, I'm gonna encourage people to take their seats. We're gonna hear 2-minute updates from the people who are reporting back from the breakout groups. So please take your seats. Okay. I'm going to do my best to keep us on time here. So please take your seat. Could I ask people who are note takers, who are reporting back for each group, please come up to the front now, and we'll just have you sit at the table up front. You're all going to have 2 to 3 minutes, 2 minutes, Prof. Sonke says, 2 minutes to report back. So if you're reporting back for your group, please come sit up front. Okay, thanks. Great. I see 3 folks here. I'm guessing modeling, climate. Biodiversity, okay. Who from modeling is reporting? Okay, so we'll have modeling online, and then Michelle, are you reporting or someone else? Evan is reporting for biogeochemical cycles. Michelle's done enough. Thank you, Michelle. Who is reporting for feasibility? Who is reporting for feasibility? Ian, come on up, Ian. Thanks. All right. No, you can sit there. Yeah. Okay, so I think we have everybody. Community engagement. Who is reporting for community engagement? Oh, no, I just didn't realize you were down there. Okay. You will go last. Okay, we'll start from this end first. So we'll start with feasibility. We are going to hear just 2 minutes reporting back on what was discussed. Anything you feel is worth sharing. And please introduce yourself briefly.
Yes, hello. Hello. Hi, my name's Ian McCubbin. I work at the Jet Propulsion Laboratory. We had a very useful meeting on feasibility with some very helpful experience from Peter Griffith. I want to give him credit. Thank you. At a first level, what we decided is that there's really 3 types of observations that we're trying to make here. There's satellite-based observation, airborne observations, and ground-based observations. And as we're going for requests to go into different countries to look at feasibility, if we think about it at that level, as we're making requests from agencies to agency or other governments, the subtleties of what the measurements aren't so important at the first level of feasibility. And we think we can move forward with a scoping effort to determine which countries are easy to go into. One colleague brought up the point of also looking at biodiversity or species richness or different biomes in each country to determine, maybe looking at opportunities for higher biodiversity rather than just going to one country that has a lower biodiversity. So that was a very interesting perspective as well. And then we also want to think about it in terms of how complicated it is to go into a country, not only the amount of time that's required to get into that country, but also how that is reviewed at NASA headquarters. Because as we're going up against another scoping study that's in the Southwestern United States, that might be more attractive to the funding agencies rather than thinking about trying to fly into the DNC or something like that. So we do want to, everybody's got sites and we want you to think about your sites. We want you to think about your observations, but we also want you to think about how complicated is it to get there logistically and geopolitically. And that's a really important thing to think about. And maybe just doing ground-based observations in those more complicated countries with satellite observations is the right answer. So that was the level that we got to, and I thought it was really useful. And I feel like we can move forward on that initial scoping effort in the coming months to say ground-based, satellite, or airborne. And then we can get into subtleties from that.
So my name is Paul Moorcroft. I'm a professor at Harvard University in Cambridge, Massachusetts. So I'm summarizing for the Biodiversity Structure and Function Group. And first, there was a discussion really about what the scope of the tropical forest definition should be. For example, should it include forests which are very heavily impacted by humans? And the general consensus in the group was that, yes, those kinds of areas should be included. There was also a discussion around the question of montane ecosystems, montane forests, and really, I think about what are the particular things for which montane forests are very important If so, what are those things? And second, what is the feasibility of making certain kind of measurements in montane ecosystems? Okay, the rest of the time was really a lot of discussion about the question of the definition of biodiversity. What does it include? Does it include animals as well as plants? The general consensus of the group was that the definition should include animals as well as plants, and not just large animals such as elephants, but small animals such as things like insects, which can also affect canopies. And then the discussion about diversity and what should be included and what should be the focus continued. And there was a suggestion that we should first identify the science question being asked, because the question itself will strongly determine what are the key aspects of biodiversity for that particular science question. And so we should be using that to focus things. And finally, now we're out of time, was about the potential role of experiments and observations while experiments are happening. No, we felt that those would come from the other groups. Yeah. Yeah. Yeah, but Helena just pointed out, we did have one, maybe you want to summarize for this.
Well, I would just say that there was a point out that the mechanisms part of the questions that have been proposed was something that we needed to think more about how to address the mechanisms, not just patterns.
Hi, I'm Robinson Negron Juarez, Berkeley Lab. I'm reporting for climate habitat and interactions. We have three main topics, data, and actually it's no data, process, and tipping points. About data, Cyril Bendian mentioned there is no data in Congo to study impacts of climate change on the forest. And Michael Coy mentioned at least we need sensible heat flux, latent heat flux for ecological studies. About processes, I believe the more relevant questions are what do individual processes contribute to climate impacts? And then we need to formulate climate questions based on those processes. And there was also a question how to, under the story, respond to climate change. And about tipping points, what is the threshold for plants? We don't know. How to correlate plant changes with climate change, and how to quantify tipping points could be through forest degradation, effect of high temperature, PPD, water availability, etc. Thanks.
All right, I'm Evan Gora at the Carey Institute, and I'm going to be summarizing for the Biogeochemistry and Carbon Dynamics Working Group. So we had a fairly wide-ranging discussion, but we talked quite a bit about axes that we need to be covered to encompass, variation in biogeochemistry and carbon cycling. We sort of settled on, the importance of disturbance history, land use history, climate characteristics, potentially just a couple axes of those, soil characteristics, maybe replicating across some evolutionary history. But a lot of our conversation was about composition and talking about covering that as well. And I think there were some differing opinions about exactly how we would cover some variation in forest composition, but they came up as something that was thought to be really important. Related to that, we talked also a bunch about measuring at scales and sort of like what we would gain from measurements at different scales. Potentially having airborne campaigns that cover very large scales, but then something that has a high temporal frequency. We discussed the need for that high temporal frequency measurement. Yes, and specifically we talked about drones as potentially filling that gap, dealing with the cloud cover issues and some of the other challenges related to measuring in tropical forests. And I think that is maybe under 2-minute summary. I think that's our summary.
Hi, I'm Shivani, postdoc at Columbia University, and I'll be presenting for socio-ecological system. So if you guys remember, we were talking about a figure in which we discussed that the feedback loop between socio-ecological system was missing, especially under the constraint of biodiversity loss and climate change. And we also discussed about tipping point again today, where we were looking at what will be the tipping point in the ecological system, which will completely impact the social system, and what will be the alternative stable state later on. And we looked at, then we spoke about what will be the data which we will collect for socio-ecological system. And then we discussed about the wish list and what will be the realistic and the most important data collection point. And then Glenn has an idea about modeling and testing modelings.
Okay, hi, Glenn Bush from Woodwell Climate Research Centre. So sort of a big science question that we might be able to tackle with improved data and sort of understanding of the basic functioning of the systems is to model basically how social values are impacted by a changing climate or landscape, and then also how those changes in social values affect choices on how resources are used or how landscapes wind up. And we also thought about selection of these super sites based on not just the biophysical characteristics, but also looking at different social systems that exist in or around them. So, you know, from indigenous peoples' use of forest systems, smallholder agricultural systems, and sort of industrial commercial systems, because then that links very concretely to end users around policy decision making.
I am Virginia Zombecker. I'm the managing director of the Congo Basin Institute, and I am reporting out for the community engagement and research application group. Our group bridges the gap between some of the aspirational things that we've heard throughout this day about wanting PANGEA to be useful and applicable in the real world with the reality of what it takes to translate science to policy and science to action. And so our group is tasked with the massive job of trying to create a bi-directional flow of information between science and communities and people who they use science.
Just hearing that your mic. Okay, even though it works for us.
Okay. There are a number of constraints that is important for all the people in the science group to hear and think about as you move forward. The first is funding. We all know that there's significant constraints on NASA funding for foreign collaborators, and it's something we need to address and deal with. The second is a difference between what constitutes a cutting-edge scientific question that US scientific funders are interested in working with and the kinds of questions and data that's needed in the real world. There's a serious gap there that we need to acknowledge. And bandwidth and capacity differences between the people sitting in this room and the potential end users. That being said, we also have a number of assets to pull from. We have existing networks of youth, of women, of indigenous peoples that we can draw on. There are funding streams and projects that already exist in many of these regions. And our group as a whole understands and appreciates the important regional differences that exist between Latin America, tropical Africa, and tropical Asia, which are going to be critical. So what are we doing now? The first is that we are improving and rolling out an important survey that Adea showed the first part of during the updates that we're going to be encouraging everybody to put themselves and other potential collaborators into. We've also been having a number of important conversations about terminology and what terms are and are not appropriate to use. What's coming up next is the improvement and the sharing of that survey and the use of its results. Figuring out how to do this work with limited resources, who we can pursue, what groups we can really pursue to work with, and who we can't. And finally, to crosswalk what scientists are interested in, what communities are interested in, to try to find the space in the middle. So we talked earlier this morning about how the tech evolved substantially over the course of LBA and above, and our group would really like to see that same evolution in how community engagement is practiced as part of science.
Sorry, we have one group left. The modeling and data synthesis group. And can you remind me, Marcos, who is presenting? Jeremy, can you please unmute yourself and speak?
Hi, can you hear me?
We can, you're on.
Okay, so we spent a fair amount of time just talking about our process and if our working group is even necessary. And we ultimately decided that it is, but that I guess we feel like integration, not just between our group and the others, but probably across all the working groups. So integration is just incredibly important. And we feel like one way we might do that is for more people from the modeling synthesis working group to also participate in other working groups and vice versa. So our working group leads have said over and over that, you know, our working group is open to everyone, and it would be great to have more measurement people. We think our working group is needed largely to deal with kind of model specific stuff. So, you know, which models are we going to use? How should we calibrate and test them? How should we quantify and reduce the uncertainties in these models? But, you know, in terms of developing scientific questions, we have, I'd say, kind of been working sort of in parallel and with some redundancy to the other groups. And so we think we may have an inflated opinion of ourselves, but I think the modelers think that we could play a useful role in developing scientific questions, but we should probably do that through participating in other working groups. And the modeling synthesis working group would be more to deal with kind of more techie model specific stuff. And we really, at this point, don't even know what kind of models we might use or what synthesis tools. Process-based ecosystem and land surface modelers, I think, are pretty well represented. And so at least some of us are imagining that might be one type of model that would be used in this project. But, you know, the social ecological systems, they may need a different type of ecosystem model. It may not be the same model that others work on. So I think across all of Pangea, we need to, at some point, kind of think more carefully about what kinds of models are needed, and that might have implications for how some of the working groups are structured.
Great, thank you. All right, let's have another round of applause now that we have heard from all of the working groups. So I'll ask you all to take your seats now. We're going to move into the next and final session for the day. As we are preparing for that, I just want to really, truly appreciate all the work that has been going into these working groups and the feedback we got today. This is a monumental task to define the scope of this campaign. And I think there's a lot of clear need to define the geographic scope so that we can hone in on certain things, while also defining the scientific scope. So I just want to appreciate again how much effort is going into this by especially the working group leads, but also the people who are involved in the working group activities. I'm now going to hand the mic to Dana Chadwick, who'll be chairing our next session. Oh, yeah.
All right, so thank you, Elsa. So yeah, I'm just going to be chairing this session. So I'll be up here briefly at the beginning. So the agenda for this session is to kind of talk about the capacity building mandate motivation from the scoping effort perspective, talk about some successes from LBA, and then have an open discussion, which I'll kind of help to facilitate here. so this is the, I'm going to just kind of frame it here, and then I'm going to hand it over to Elsa to talk a little bit more about kind of the larger context and then some of the takeaways from the Cameroon workshop that was that we'd like to share. But this, you know, the capacity building component is really fits into the core of what terrestrial ecology field campaigns are intended for. And I think that, you know, Elsa has done a really amazing job of kind of being thoughtful about this from the very beginning, as have so many of you who've been contributing to these efforts. And I just want to take a moment to say that capacity building really allows all of these questions to be answered both now and into the future. If we're not constantly building new capacity going forward, then we're not going to be able to have the next TE scoping campaign and the next one and the next one. And so we're never going to kind of build that ability to kind of learn as a large community together. And so I think this is just such an important topic. So I'm going to hand it off to Elsa, who's going to talk a little bit, starting with the motivation component.
So I just want to highlight this interesting, I love these maps because I think they just emphasize important points in very compelling ways. So the formatting is a little funky here, but what you're looking at on the left are science papers, not from the Science Journal, but any scientific article that was published in 2005. And on the right, you're seeing the same thing from scientific articles that were published in 2016. And the territory size is proportional to the number of articles published from that place in that year. So I think, you know, if looking at the left map in 2005, in both maps, there's clear disparities between the global north and the global south. That sticks out immediately. And then I think there's been some improvements, minor, in terms of increasing articles being published from South America and Asia, and that's remained incredibly thin in Central Africa. Something I want to just emphasize and highlight here. But in general, this disparity is exactly the sort of thing that I think PANGEA can contribute to addressing. I want to emphasize and just kind of spotlight a really nice example of a recent airborne campaign that was led by NASA called Bioscape in South Africa. This was a really close partnership between researchers and institutions in the US and South Africa. And you can't see everything here. You're not meant to. I would encourage you to go onto their website and take a look at what they've accomplished. This is just emphasizing the network of people involved in that process, and everybody in pink, highlighted in pink, is from a South African institution. And that's also something we want to emulate with PANGEA, is really bringing leaders from local institutions to play a role in this. And we'll come back to capacity building and what that means for PANGEA across career stages. But I think a big part of this is engaging researchers from these regions. And that can be a challenge with NASA. But as you can see here, it's being done. It has been done. There's ways to creatively do that. One thing I also want to emphasize is this really nice paper that came out in Nature, Ecology, and Evolution a couple years ago about making forest data open and fair. This is forest inventory plot data specifically that this paper is referencing. And we mentioned this earlier, just the importance of recognizing that field work is less costly than remote sensing work, but it needs sustained investment and it can carry substantial risks. And countries that hold the most tropical forests are also the least able to invest in science and development. Something that also is, I think, important to emphasize here, NASA has this incredibly important open science emphasis. It's so important. What I'm going to say next does not take away from that. Thinking carefully about what open data means and for whom and who has access is an important part of that open science conversation. Data, I think by default of our infrastructure, technology, accessibility is often quote unquote served up to the global north, and thinking about true accessibility and involvement and is important, and not allowing that to further entrench structural inequities. I'd encourage you to read this paper. It talks a lot about recommendations for how to overcome a lot of those challenges. A lot of